My name is Phoebe Vallanos, and I'm an assistant professor of industrial and systems engineering and computer science at USC. I'm also one of the associate directors of the Center for Artificial Intelligence in Society at USC, where we're virtually hosting this event. It is my honor to kick off today this CAIS Spring Symposium on equity and AI. And I'm going to be able to switch slides. So first of all, I just want to wish a warm welcome to everyone on behalf of all of the organizers. Eric Rice, our center co-director, who's also an associate professor in the School of Social Work at USC. Myself, Caroline Johnston, PhD student in Industrial and Systems Engineering at USC. Shadi Saba, PhD student in the USC School of Social Work. And also a warm welcome from Ty Hines and Haley Weintraub, our staff, without whom this event would not have been possible, and at which point I'd like to say a huge thank you to. A bit of an overview of our event. It takes place over 2 days. We have 3 hours each day from 10 a.m. to 1 p.m. Pacific. We have 8 keynote talks, 4 today and 4 tomorrow. These involve 10 keynote speakers. We have 2 actually joint talks. Today, we will also have 9 invited talks split in 3 sessions. At the end of each session, we will have a short panel discussion. Tomorrow, we'll have a poster session that will involve 12 poster presentations. As of yesterday, we had 120 registered participants, so we look forward to vibrant discussions. Our keynote speakers and panelists span a huge range of domains, ranging from computer science and operations research to the social and political science. We really have an all-star lineup, both from the keynote speaker side and the panelist side, and also in our poster sessions. I'm just like flashing a few of the people here that will be involved and that we're really happy accepted to take part. Our panelists involve experts both from industry and academia, and we're really excited to learn from them. For more detailed information and for the precise schedule, you can check out our Google Sites Symposium on Equity and AI. For any technical concerns, today please contact Shadi at ssab@usc.edu. And tomorrow, Caroline at cmjohns@usc.edu. You can also ping them over Zoom. Have a wonderful time. Enjoy this symposium.
All right, I guess it's up to me now to kick off the introduction for our first keynote speakers of the day. No pressure to them. But first, we'll be hearing from Sanmay Das and Patrick Fowler. So I'll give a brief introduction of them first. So Sanmay Das is a professor of computer science at George Mason University. His research interests are in designing effective algorithms for agents in complex, uncertain environments and understanding the social or collective outcomes of individual behavior. Dr. Das is chair of the ACM Special Interest Group on AI, a member of the board of directors of the International Foundation for Autonomous Agents and Multi-Agent Systems, and serves as an associate editor of the ACM Transactions on Economics and Computation and of the Journal of AI Research. He has been recognized with awards for research and teaching, including an NSF Career Award and the Department Chair Award for Outstanding Teaching at Washington University. And now to introduce Patrick Fowler. Patrick Fowler's research aims to prevent homelessness and its deleterious effects on child, family, and community well-being. Trained in child clinical community psychology, he uses innovative methods that rigorously investigate policies and programs intended to promote housing and family stability. His recent research focuses on cross-system collaborations to prevent child maltreatment associated with family homelessness, as well as youth homelessness in the transition from foster care to adulthood. So let's all give a warm welcome to Sanmay and Patrick.
Hi, can everyone hear me? Okay, great. I'm texting with Patrick, who is trying to get on, but I think having some technical issues, and of course is super well planned because he was going to start the talk. So I guess I can just get going in that case. Hopefully he will be able to.
Can we help him somehow?
I can send him the link again.
Yes, actually, if somebody could send him the link, because I'm trying to send him the link, it's
Okay.
absolutely garbled. So I
I'll
think
do that.
might be helpful.
Yeah, no worries. It's the first minutes of the morning. I think a few login hiccups is to be expected.
I think I was trying to send him the link. Unfortunately, my email like munges all the links that I get through a Cisco something or the other, and so I think it's incomprehensible. But anyhow, hopefully he'll be on soon. I think.
Okay, I just sent it. We should get it soon.
Okay. I mean, I could start in the interest of time, and in the worst case, I'm sure he'll be on by the time that there's discussion or questions.
Here he is. He's coming.
He's here? Oh,
Yep.
Beautiful. Fabulous.
Patrick, just in time. Welcome.
That's the way I do it. Except I think I was in the audience and I was saying, I'm here, I'm here, I'm here.
I think you're up, Patrick. You've been introduced. And,
oh, great.
And it's, do you want me to share the screen and move on? And then, yeah, I can do that. Okay, so. Yeah.
So thank you for having us. As Sanmai is pulling this up, we're going to give a quick overview of stuff that we've been working on that has been, I guess, 8 years in the making. So we've been involved in a ongoing community partnership to improve homeless services in the St. Louis region. And the title of our talk is Sanmai's pun, about justice resource allocation. So everybody laugh hard because I've worked on that really hard. Go ahead and advance. So in terms of justice, we do want to talk about ways that we should and should not consider how to allocate scarce resources. So we are rooted in a longstanding history of economics research, longstanding history of philosophical debate of how do you deal with these scarce resource allocation problems. And in our context today, what we're talking about is homeless services, where we have, it's just hard. It's hard to determine who should get what when you have so many competing interests and from multiple levels. So go ahead, Sanmai. I think you probably all know this given your work in LA, but so homelessness is guided by federal policy. Every community in the country is required to set up a system to respond to emergency housing needs. We've gone through many iterations of how these services are organized, and we're still struggling. So we have a lot of people who need help without enough resources to provide it. And as this is another Sanmai term, it's a base problem where this is a thing that we need to do. We need a house as a platform. So to improve public health, we need to address housing stability. Okay, go ahead. Yeah, so I already said this. One thing to point out that the typical homeless system is offering a variety of services that range from emergency shelter, so I don't have a place to stay right now, to emergency short-term assistance, like 1 month's rent or a couple months rent, to even longer-term housing supports, ongoing housing subsidies. So there's a range of options. People prefer some over others. Go ahead, Sanmai. The work that we're going to be talking about is it was in our last economic recession. So this is work done right after the Great Recession, where homeless services had reorganized itself to offer these basic supports, so emergency shelters, transitional housing is a 24-month, up to 24-month supportive housing option. Rapid rehousing is time limited in St. Louis. It was more like 3 months of supportive housing. And then homelessness prevention, which was really light touch services. So this was the 1 month's rent, the help moving in, the utility deposit. And what is unique about St. Louis is at the time we had a central system. So this is, if folks know coordinated entry, this was how coordinated entry should have been done, where you have a single entry point for all housing responses, not just those that met certain criteria. And what it gave us the ability to do is kind of track community-wide demand. So we're using data we can see community-wide who's coming in and out of the system. Go ahead, somebody. So we've got in our time period, so 7-year time period, 14,000 households. We have re-entry, which, if you look at this, you see homelessness prevention. So 14% of those who received homelessness prevention returned or needed assistance, requested assistance within 2 years. And you think, well, that's great. Homelessness prevention should be really good. Way better than emergency shelter, where the return rate was 43%. But these are, of course, biased. So these are unadjusted reentry rates. And so we've got this problem where we've got to figure.
Patrick, you're getting cut off every now and again.
Yeah, sorry. So we've got this challenge of who do we provide assistance to that will benefit both the individual household as well as the system-wide availability of resources. Go ahead, somebody.
All right, so I think this is the point at which I will take over. So I'm going to talk I want to talk about sort of a couple of different things that were kind of inspired by this framework that we then began to work on. Some of this basic stuff I talked about when Phoebe had last invited me over to USC a few years ago, which was a really great visit and spurred some of the thoughts that have gone into this research since then. But essentially, I guess the first problem that we got interested in when we were looking at this data was this question of just, okay, within the limits of the system and those people whom it managed to actually support at the time, are there potential efficiencies to be gained by doing a better job of matching households to services, right? And so the simple sort of cartoon way to think about this is in this kind of picture. So suppose you've got green are households and red are services, right? The empirical question is going to be sort of, are there gains to be had? And I've got sort of two opposite ends of the spectrum over here in a really simple version, right? So think about these numbers as sort of positive utility values, right? In the first, in this slide in the part on the left where it says homogeneous, what we've got is we've got two resources. One of them is a value 3 resource and the other one is a value 8 resource, and that is the case no matter who gets assigned to that resource, right? So this is a situation where, let's say, transitional housing is a very powerful support and it's a powerful support for everyone, and therefore whoever gets matched to the transitional housing resource will do better and whoever gets matched to emergency shelter will do worse. At the other end, we might have significant heterogeneity in how people respond to these different types of resources. And there's a lot of evidence from that, especially from Patrick's prior work on prevention, that there are, households who we may be sort of, giving too intense services to, and they would actually be better off if we let them make their own decisions with appropriate sort of levels of support. And so here's an example where, for example, if I went with the straight match over here, I would get a social welfare of 6 by matching the top agent to the top resource and the bottom agent to the bottom resource. But if I went with the diagonal match, I would actually end up getting a social value of 16, which is much higher, obviously, in this case, because it just turns out that the top agent is better matched with the bottom resource and vice versa. Right, so obviously this is a cartoon. It's really an empirical question of like, does this exist in practice, and if so, how much? And that was kind of the first set of questions that we were interested in exploring. And so we began to think about this as an assignment problem, right? For those of you from the AI and OR, you've seen many assignment problems, but again, to give you just a really simple value, suppose we've got 3 different interventions, and we've got, intervention 1 has capacity 1, intervention 2 has capacity 2, and intervention 3 has capacity 1. Then we can assign sort of one agent. This is sort of the efficient assignment, right, that maximizes overall kind of social utility in this kind of a case. So we're going to think about it in that manner. And so these are fairly recent results that are going to bring into question, right, can we use this data set that we've accumulated to try and actually figure out, these counterfactuals of how well matched is a household to a particular intervention. And so the question that arises over there is sort of, that obviously we've got this massive sample selection bias that Patrick talked about. And what this is, and why this is different from other work, that's been done in recent years on this kind of, machine learning combined with assignment problems kind of thing, is the other sort of famous example where this has been used recently is in refugee allocation, especially in European cities. The big difference over there is that they have essentially quasi-randomized data on prior allocations, right? So they've basically prior allocations of refugees were randomized, and so you have, so by applying machine learning techniques to that, you can be pretty sure that you're able to kind of do a decent job of predicting how well a particular household will do when it's assigned to a particular city. We don't have that because obviously there's this massive selection bias in where caseworkers were assigning people in the past, right? So so what we did was we examined various different machine learning algorithms with the idea that what we wanted to use was one that's good at counterfactual prediction. And there's some evidence that this method called BART, Bayesian additive regression trees, is a good method for counterfactual prediction. And so we did some analysis that basically showed that not only, does it have that theoretical benefit, it's actually as good as most of the other standard machine learning techniques you would use, like gradient boosted trees, on the standard kind of out of sample machine learning metrics for prediction on sort of, how well do families do when they're put into particular interventions. So this kind of grounds our decision to use BART. And just to, I'm running a little bit low on time, so I'll kind of run through some of those results a little bit. But basically, we showed that if we were able to re-optimize the allocations using these BART counterfactual predictions of how well households would have done, we can reduce our overall re-entries from 27.5% down to 21.5%, right? Which is actually pretty substantial, because even if you were to give each household the best intervention without worrying about capacity constraints at all, the best you could do would be to get like 18% predicted re-entry within the next 2 years. So we're able to sort of cut, a fair amount. We're able to cover a fair amount of that gap between the best that we could possibly do with no capacity constraints and what we're actually observing in practice. So that's kind of exciting and points the way towards interesting work. I want to talk briefly about the considerations of justice and equity. So we looked at sort of who is helped and hurt in this reassignment, and we find that about 40% of households are helped. That is, they have a lower re-entry probability, but we're still, it's not Pareto improving. In order to do that, we're hurting 28% of households. Interestingly, we found that the ones that we're helping more are ones with lower monthly incomes, longer waits, more calls to the hotline, or where the head of the household has a disabling condition, which implies that actually, the more vulnerable households are potentially being helped more in this reallocation process. So, so that was kind of exciting. In work that we've been doing recently, we've actually been trying to sort of, put this into a more formal framework and connect it to work in political philosophy that looks at how local institutions allocate scarce resources. And basically in this case, one way to think about it is there's a particular set of allocation mechanisms that use notions of individuals and the interventions that they're assigned to. And I won't go through all of this in detail. I'm happy to talk about it more if anyone's interested, right? But the two that have been studied a lot are obviously the utilitarian or the efficient assignment, which we talked about earlier, and sort of the Rawlsian or, max-min notion that is often in CS and OR formalized as leximin these days, right? Which is to say, okay, you maximize the minimum utility and then subject to that, maximize the minimum of the remaining and so on and so forth. And we're actually investigating a third alternative that John Elster talks about, which is the so-called increment criterion, which says you should prioritize those who can benefit the most, which actually turns out to be different from either of the other two ideas that we've just talked about. It's essentially, it's leximin over regret, if you like to think about notions of regret in machine learning. And it's been used in situations like battlefield triage, for example, or people were talking about this a bunch when we were really worried about intensive care units and ventilators in the first sort of COVID wave, and who should be allocated these kinds of resources. So there's the same idea of a different prioritization scheme. And if you look at that, it actually turns out that, while it's distinct from the efficient scheme, it actually typically comes closer to efficiency than it does to leximin, which might sort of help to explain to some extent why it has been a political choice to use that notion of prioritization in the past. And so we're interested in sort of thinking about what this idea of prioritizing by incremental gain might tell us about notions of who should get what in these kinds of situations, as compared to say VI SPDAT or something like that, which really prioritizes by most vulnerable first, which you can think of as more like leximin. These are the main takeaways that I've talked about. I won't go into detail because I want to give Patrick sort of a minute to come back in to just talk about our last slide, which is on ongoing work that we're doing. So take it away, Patrick.
Yeah, I just want to real quick emphasize that this is an ongoing community collaboration. And so what we're not talking about is all of the checks and balances that we've created with our community partners to understand what we're finding. And unfortunately, the COVID economic recession has kind of, it's a blast from the past, it's deja vu, where we are supporting St. Louis in really tough decisions about rental assistance, which there has been $50 billion allocated in federal rental assistance for low-income households as part of the 3 stimulus packages. And just to put that in context, the normal homeless budget is about $2 billion. So this is a huge increase. And communities have little capacity to make these timely matches. And it raises really big concerns that if we're not doing this better, we're gonna miss opportunities to help a lot of families and waste a lot of resources very quickly. So we are in a good position to help in thinking through this through. So it's just been a really fun partnership.
Awesome, thank you. Virtual round of applause. Thank you both, Sanmai and Patrick. We have a few minutes for some questions. I guess I'm technically kind of moderating the questions, so I can read them to you both. And again, I encourage anyone in our audience, if you have questions, please do put them in the Q&A box so that we can field them. So Dan Ho in the chat says, really interesting work. One of the open questions with the refugee matching work, which maximizes labor market integration, is that it may reward local labor market discrimination, i.e., don't send certain refugees to a particular city because of bias. He's curious whether there are similar concerns here in your work.
I think that's a really interesting question. I can't think of anything off the top of my head that would be similar because, I mean, at some level, that's sort of a locality that's making a decision, right? In our context, what we're thinking about is homeless service providers and sort of, other resources that could be provided that are always kind of in the business of trying to serve their communities the best, right? Now, is there something insidious that could somehow come in? Basically, like, and I don't know, Patrick's more the expert on this. I could imagine a situation where if different providers are being evaluated and compensated differently based on, you know, metrics that they're trying to optimize, like re-entry rate from your particular shelter or your particular intervention, I could actually imagine it in those cases potentially spurring, you know, bad behavior by trying to like make them act in ways that would get them the populations that they want to minimize their re-entry rates. I mean, that would be the standard kind of concern, because it's a really, really interesting question. I would think off the top of my head that that's a little bit unlikely in this situation, but I will defer to Patrick on that.
Yeah, I mean, it's right now my biggest fear are landlords, where landlords are having a disproportionate decision-making process of whether they want to accept rental assistance for a household in need, or whether they want to maybe evict so that they can get the next family who has rental assistance. And I am very concerned about the unintended consequences of offering up rental assistance where we're not thinking through some of these insidious actors. So not exactly parallel, but when you flip the market, yeah, I think they're there.
Wonderful, thank you. I think we have time just for one more question. So Eric Rice actually is wondering, or he is very interested in how the community partners understand what notions of fairness or prioritization is most desirable.
Yeah, so is this, yeah, so here's what I can say. So in our work, we started before coordinated assessment, and we started before the VI SPDAT. During our work, communities quickly figured out that they have to rush to the bottom. They need to find the most vulnerable and help the most vulnerable in order to get funding from HUD. And in that rush to the bottom, they recognized that they were not serving families very well. But that federal policy context still exists. Our work has given them a different language, I think. You know, our collaboration has created different language around, you know, moving away from vulnerability and moving towards gain and equity. So this has been, you know, we're continually having this conversation. We've not won over the purse string holder HUD, but we are doing our best.
I'll just add that sort of one of the things that has been really interesting to me in this is that, you know, we got partly, I think, also inspired by some of the stuff that you guys have been doing and that, you know, Phoebe has talked about and that Duncan McElfresh did with you guys, I think, on trying to sort of actually understand, you know, what stakeholders' preferences would be, although in a slightly different context. And one thing that I found super interesting is just how at all different levels of the chain, ranging from, you know, caseworkers and the people who are making the decisions on the ground, up to the community level sort of organization, up to the federal level, right? There's disconnects between their incentives at sort of each layer of this. And I think that that's part of what makes it really tough, right? Because everybody is locally responding to their incentives. And they may express their preferences in ways that are very locally responsive while still making the whole overall system very, very difficult to deal with. But this is something that I just find absolutely fascinating. And I would love to at some point talk more with you guys about this as well. So.
Yeah, and I'll end with a quote from a homeless consumer that was part of some of our work. The way that he put it was, teach a man to fish, or give a man a fish, you feed him for a day. Teach me how to make the fucking rod. so yeah, I think this is, yeah, I'm going to end with that.
Yeah, what a wonderful way to end. Thank you both so much. What wonderful and important work that you both are doing. Thank you. Awesome. Another, yeah, virtual round of applause. All right. And with that, I suppose we will be moving on to our next speaker of the morning. So I believe Kai will be in the process of promoting Dan. Hello, Dan. Thank you for being here. And I will go ahead and have the pleasure of introducing you formally. So Daniel Eho is the William Benjamin Scott and Luna M. Scott Luna M. Scott, Professor of Law at Stanford Law School, Professor of Political Science, and Senior Fellow at the Stanford Institute for Economic Policy Research. He is also Associate Director of the Stanford Institute for Human-Centered AI, Faculty Fellow at the Center for Advanced Study in the Behavioral Sciences, and is Director of the Regulation.
And that the risk that we should fear most is not the risk that we can easily imagine. It's the risk that we don't. It's the innovation that never occurs and the knowledge that is never created because you've ceased to lay the groundwork for it. And nowhere has that been more on display than in COVID-19. So as the New York Times reported, the bottleneck for US coronavirus response in a number of jurisdictions was literally the fax machine. In Harris County, one quote is picture the image of hundreds of faxes coming through, each reporting diagnosed instances of COVID-19 and the machine just shooting out paper. But it's not just a technical problem. In Santa Clara County, as elsewhere in the country, there are dramatic disparities in case rates. So while about 25% of Santa Clara County's population identifies as Latinx, the case rate for Latinx individuals is about 57%. And so the big question that we began to tackle over the past year is how can we use AI to advance public health equity? And our kind of theory of impact has long been that the AI community and the data science community often seem like have this gulf between policymaking communities. And so we built up a partnership with the public health department here in Santa Clara County, which is this paradox of a county where you have both Silicon Valley, but more sort of an agricultural community in the South and real disparities in terms of income. It's also the first county to implement the shelter-in-place order in the country. And I'll give you 3 examples of how we moved in this particular direction. The first was that we were asked by the public health officer to help us understand a little bit more about mobility, what mobility data can do to inform the public health order. And as most folks here probably know, there have been hundreds of papers written with mobility data that all build kind of ML and AI pipelines on top of this data set, particularly by SafeGraph, that uses information from 47 million smartphone devices. And nearly all of those papers assume that that mobility sort of information is ground truth. At the same time, we know extremely little about what actually makes its way into this data ecosystem. And so with a number of co-authors, we really tried to think about how we would test for disparate coverage, which is hard because you have to have ground truth for visits to places of interest that exist within that SafeGraph data. And you also have to have demographic information about those particular visitors. We spent a whole bunch of time thinking about this. And what we ended up landing on was a solution that uses administrative data, where you can actually look at voter data of where people voted in person on a particular day, match that up with the places of interest that exist in the SafeGraph data. And then what we basically showed in this paper was that we're seeing real disparities when you look at voting places by age composition of each voting place and coverage of what is actually picked up in that SafeGraph data. So to think about this intuitively, basically polling locations that disproportionately serve older voters are much less likely to be represented in this mobility data, which is of course of great importance given that age is the main risk factor for COVID-19. It also interacts with race. So what we found is that those voting locations with disproportionately minority voters were also less likely to be represented in this data. And for us, what's interesting about this is that this is a general approach of how we can start to actually audit these kinds of data sources when a really important practical challenge is that protected attributes are often missing from these kinds of data sets. It's also kind of astonishing that it's a lesson we keep relearning over and over again. SafeGraph literally describes itself as, quote, the source of truth about physical places. And of course, we've known from many studies now that simply having 47 million devices is not a substitute for understanding the representativeness of data. And for us, probably the most exciting thing here is that it will also hopefully lead to better ways of actually debiasing the reliance on this kind of mobility data. Second example comes from our efforts working with an amazing team that was running the contact tracing process for Santa Clara County. And this was an extraordinary effort by the Public Health Department. Within a matter of weeks, they went from 0 to nearly 1,000 contact tracers. This was stood up in rapid time. And as a result, there were all sorts of pain points. And one of the particular pain points was that as COVID-19 diagnoses came in, there was no way to match those cases with the language skill sets of the 1,000 contact tracers that they had on staff. In other words, it was essentially randomly assigned. And as a result, there were really significant concerns about whether contact tracing as a result was much less effective because it effectively doubled the time because you had to call into the state services to secure a translator for that particular language. Everything had to be repeated. It was much harder to build rapport with individuals. And so what we built out is we merged in kind of census data, built out a kind of ML pipeline to basically predict the likelihood based on the information that's available in the test report to predict whether someone speaks English as a second language and whether they speak Spanish as a primary language. Interestingly enough, what might be of interest in this community is that there was a fair bit of time there making sure that the methods we built out really were interpretable by public health officials, because this was going to change the actual case assignment to match the language skill sets of contact tracers to incoming cases. I'll give you just a little bit of a flavor of what that looked like. Is we basically turned what could have been a more complicated model into a kind of heuristic, where here on the x-axis we have like age bins, sort of address scores based on the proportion ESL in a particular census block group, then first name scores based on HAMDA data, the mortgage data, and then last name scores based on census data. And basically what that resulted in was a kind of heuristic that was really much more easily explained of, it's really in this quadrant where you have the highest proportion of individuals that are likely to be ESL Spanish speaking. And let's basically let's create a kind of heuristic that we can all agree on the kinds of cases that should be routed to Spanish speaking contact tracers. The result of that, which we designed as a randomized controlled trial, was that the demand for interpreters went down by 15% amongst this language specialty team, and the likelihood of providing contacts increased by 10%. And we then ran a survey of the folks who had been doing the contact tracers. And here's just one quote that I really like. In general, people were pretty happy with this idea of being able to actually use their language skill set. My experience has been overwhelmingly positive. I think the one-to-one communication in the client's language has helped me to establish rapport and elicit more contacts. It also helped in promoting isolation and quarantine compliance and relaying information on health monitoring. And I hear a lot of appreciation from clients that adds significantly to my satisfaction doing this kind of work, when this is not like an easy job to do, to be the kind of first government contact after someone has been diagnosed COVID-19 positive. Third example I'll give you is about testing resources. And here, what I'll focus on is the fact that there are dramatic disparities in testing resources across parts of the county. So this is a map of the positivity rate, the number of positive tests over all tests conducted, which is typically seen as the diagnostic measure to see whether we have adequate testing resources. Kind of rule of thumb might be if you have above a 5% positivity rate, that suggests testing resources are inadequate. And what you can see here is their parts of East San Jose. This is sort of where Stanford University is located. This is East San Jose. And this is the southern part of the county that has more agricultural workers. That's where you see the darker shades of much higher positivity rates where testing resources are likely inadequate. I'll add to that compare that to just a map of poverty, and it just correlates extremely highly with poverty in the county. And what's worth noting here is that even pop-up testing sites located in East San Jose were perceived not to be reaching the community for a whole range of reasons. And so what we stood up here was a community partnership with a team of community-based health workers that were based in East San Jose, sometimes referred to as the Promotoras de Salud, to do free door-to-door COVID testing in East San Jose. And you might wonder, like, how did our team come in to all of this? Well, the question that arises, which strikes me as still a pretty important question in public health generally, is how do we actually allocate testing in the most effective way? And so what we did is we basically took this area of East San Jose, split it up into walkable segments so that the teams of promotoras could visit particular households. And then the question becomes, where do we send them to really ensure that they're most effective? And through a series of conversations and working through alternatives and talking to our infectious disease colleagues here, there are basically three strategies that were on the table. One was the one that the infectious disease colleagues favored the most, which is go to where the cases are. So if you have a diagnosed test, that's the household where you should be sending the promotoras to conduct tests. Sort of like look for you know, where the light pole already is, go there and test individuals in the index case household. The other one was that the team of promotoras really felt that, hey, we may have local knowledge about an event that occurred because we live in these communities. So let us have some discretion to be able to use local knowledge to go where to test. And then the other one was really borrowed from the kind of multi-armed bandit kind of literature on the positivity rate. So this was uncertainty sampling based on the upper confidence bound of the positivity rate that was highly localized, that we could use based on the county data to see where were we the most uncertain about a very high positivity rate. And I'll walk you through the results really quickly. The first is that when you look at the demographic reach, here's the County Fairgrounds testing site. Here is the closest testing site at the Emmanuel Baptist Church located in East San Jose, which reaches about 50% Latinx individuals. Here was the reach of the door-to-door testing, which increased the proportion of Latinx individuals tested by a pretty substantial margin, and also reached more elderly individuals. And then when it comes to the sort of ideal targeting scheme, what we basically found was that the infectious disease insight, which was to go to index case households, was not particularly effective. It led to about a 2% positivity rate. And one intuition for why it might not be a particularly great way to go is that if someone within your household is just diagnosed positive, you may just be really unlikely to actually answer the door and want to let somebody engage anybody who shows up, even if they're known within the community. Local knowledge, on the other hand, led to a near 7% positivity rate, which is a substantial improvement over the index case strategy, and uncertainty sampling using the upper confidence bound of the positivity rate led to a nearly 11% positivity rate, which is just kind of jaw-dropping. If you think about the way we often think about positivity rates is, oh, it's driven by symptomatic people going to get tested. That's why the positivity rate may be high. Here, it was knocking on doors to offer free tests, and amongst the individuals tested through that process, the positivity rate was 11%. So I'll close just by saying what I think is at stake here. We're shifting now to use some of these methods really to think about equitable vaccine distribution. And I think what I am hoping we will all get a chance to really think about is the kind of future of public health infrastructure. How do we think about a public governance system that enables these kinds of ways of leveraging insights of AI to have more equitable disease response. And so to me, it really is about how do we shift the kind of broken public health infrastructure that exists in many parts of this country towards something that really facilitates these kinds of interventions. I'll close by saying that nothing here would have happened without just an extraordinary team of collaborators, both at Stanford, at the public health department, and the team of promotoras and on the ground. And I'll be happy to take any questions.
Thank you, Dan, so much. What a wonderful talk. If I could be a bit selfish, I have a question. So you just mentioned about the vaccine distribution. So maybe somewhat obviously that's kind of like the door-to-door delivery of like, here, let me give you a shot in your arm. But I'm wondering if you have thought about the vaccine hesitancy, right? I find that there's a lot of parallels, right, with what you talked about with like identifying ESL speakers and building that rapport. So I wonder if there's been conversations about building that rapport, but more with efforts towards the vaccine hesitancy.
Yeah, I have been less involved in that part, but there are wonderful colleagues of mine who've done a range of focus groups. Ana Lilia Garcia, who is one of our collaborators at the county, has held a range of these focus groups really to try to understand what the barriers were. And that was really all the planning that went into why we ultimately settled on something like the door-to-door initiative, was the articulation of what are all the barriers that are preventing you from going to Emmanuel Baptist Church or going to the fairgrounds. And it had to do with things like, well, those are my work hours and I just can't go at these times, or real fears about what are the consequences for my employment situation if I test out positive, when I just can't afford not to go to work. So I'd rather not get tested. And I think Ana Lilia and several others here in the public health community and infectious disease community have done a range of those focus groups with more of an emphasis on kind of vaccine delivery. And I think, I don't know those findings in great detail, but one of the things that really was a theme that I think came out of that, those focus groups was the sort of importance of networks and who else has gotten vaccinated. So one quote that sticks out in my mind is, I just don't want to be the first. I really, but like if I know my daughter's gotten vaccinated, I'll go get vaccinated. It also mattered in terms of the strategy for signups, right? Our first priority group was sort of 65 and over, and there was a real reluctance to go because people didn't want to have individuals go to vaccine sites by themselves. And so one of the strategies we thought about was, oh, well, can we figure out how to do signups that really enable people to go like as a family unit? And it will make the process seem a little bit less daunting as a result. But it is, I think, Caroline, you're kind of hinting at the broader question, which I thought was so amazing about the homelessness work as well, which is that the intervention comes really after having done a range of that stakeholder consultation to really understand how to design what we think and hope is going to be an effective intervention. And that very much is the case for vaccine delivery as well.
Awesome, thank you. I think we have one last question here. So this person thinks about people as great intuitive data collectors and processors. They're curious what you see as the relationship between the local knowledge and the AI-driven approach.
Yeah, I think it's a great question, Eric. I think what to me was stunning is how much the local knowledge beat what a number of my infectious disease colleagues thought was like the obvious approach. But even then, what we had at our advantage was because we were working in partnership with the county, we received all of the daily testing results and could calculate like what parts of East San Jose are seem to have a really high positivity rate at a pretty localized level. And so there, that's not the kind of judgment that I think is going to be easily amenable to kind of the local knowledge. What you do get is things like, I know there was an event last Sunday and someone who attended that event diagnosed positive on Monday. Therefore, let me go to where folks who attended that event live and provide testing resources. And I think that's probably the kind of local knowledge that was really effective in getting above the positive rate of the infectious disease baseline.
Awesome. Thank you so much, Dan. What a wonderful talk.
Thank you so much.
All right. So at this point, we will be moving on to our next speaker. I think Ty will be promoting our next speaker, Dr. Nicole Turner-Lee, who I will again introduce. So Dr. Nicole Turner-Lee is a senior fellow in governance studies, the director of the Center for Technology Innovation, and serves as co-editor-in-chief of Tech Tank. Dr. Turner-Lee researches public policy designed to enable equitable access to technology across the US and to harness its power to create changes in communities across the world. Her work also explores global and domestic broadband deployment and internet governance issues. She is an expert on the intersection of race, wealth, and technology within the context of civic engagement, criminal justice, and economic development. Welcome, Dr. Turner-Lee.
Hello, everyone. How are you? Hey there, Professor Rice, and to all the students that are participating and professionals participating in this conference. I'm excited to go next. Now, I do have to caveat it that previous presentation and the rich data that was presented was off the chain in terms of just those correlations that were made. But I'm not coming with a PowerPoint. In fact, I'm going to come, I think, as a Black Baptist preacher with a few points around this whole idea of fairness when it comes to algorithms. And I know you've heard my bio, but let me just share a couple things about me that may not have been said in the written bio in the time that we have. First and foremost, I'd like to say that I'm a senior fellow at the Brookings Institution, so I encourage anyone to look up what people in think tanks do as a career option. I'm a sociologist also that is talking about algorithmic bias, so there is a space for social science in this discussion. And third, I'm finishing up a book. So a shameless plug is the new book that I'll have coming out this fall on the US digital divide entitled Digitally Invisible: How the Internet is Creating the New Underclass. And when I'm not doing those things, I spend a lot of time looking at this question of algorithmic bias and fairness, which is really the subject of my short talk. And I present this to you all in a way that hopefully, for those of you that are not as skilled in machine learning algorithms will understand, but for those of you who have been working in this space, you'll actually begin to understand some additional questions we need to be asking ourselves when we look at the role of machine learning algorithms and civil and human rights. For the most part, we did a paper at the Brookings Institution on algorithmic bias detection and mitigation. And we defined, and this was a paper that I actually completed with both a lawyer and engineer. And I tell you, it was probably the longest paper I ever did because a sociologist, a lawyer, and an engineer just makes for a great party. But what we found in our definition of bias overall is that when similarly situated people, places, and things received what we call differential treatment, where there may be some distinction between, the types of interest or lifestyles that people may have, and disparate impact, where there's a longer term collective impact that may in some respects foreclose on the opportunities available to those people, those places, or subjects. And I start there because I think the algorithmic bias space has become very convoluted with a variety of perspectives on what people think it is. And in my work, we're pretty clear that when there is a disparate impact that actually affects one's ability to sort of develop or be mobile because of the algorithm, it's a problem. And particularly when the decision actually mirrors the systemic inequalities that already affect certain populations. So in my work, I'm particularly interested in how algorithms actually impact or engage various contexts where vulnerable populations actually rest. And I'm going to actually talk a little bit about that today in this keynote and hopefully provide some time for Q&A. So let me give you a couple of examples, and I'll start with examples that you may already be familiar with, and then I'll go to examples that I like to use when I'm actually talking about this stuff. LaTanya Sweeney, who is a professor at Harvard University and used to be the chief technology officer at the Federal Trade Communications, has written papers, for example, that suggest that people with quote unquote Black sounding names or Latina sounding names tend to be offered higher interest credit card offerings or other financial services when the algorithm picks up on that name in terms of the cadence of that name. That's one example where we actually find that people who are already disadvantaged in financial services and wealth equity outside of the internet actually experience the same types of impacts on the internet because of the way the algorithm picks up on those externalities. There was just a couple of years ago a healthcare algorithm that was designed to screen the eligibility of patients for with chronic disease for a particular program. And what was identified is that particular algorithm was actually kicking out Black patients who in society have the highest propensity towards chronic disease. And why was that? The algorithm itself was trained on data that used, instead of race, a variable around the amount of investment in healthcare. And if you do the math as a social science and you look at the historical legacy of Black people's relationship to healthcare systems, you'd actually find that they don't pay as much as whites, primarily because of the lack of proximity of health institutions, but also the economic vulnerabilities. So that algorithm landed up on the front page because what it essentially did was to suggest that Black patients were not eligible, and over time could have produced a disparate impact. Amazon, my last example, actually created an algorithm to hire more women, get this, in engineering jobs at the company. They trained the algorithm on data of the last 10 years of hiring data, which was primarily composed of men. And for every woman that applied for that job, if they were Mary or Jane or Nicole or some woman-sounding name, or went to a women's college or was part of a women's extracurricular organization, they were kicked out of the system and denied the opportunity to interview. My friends, I share those examples because that's a little different than I think some of the innocuous examples that we have in terms of the distinctions that are made with machine learning algorithms. I like blue dresses and I want a company to sell me as many blue dresses as possible. But when those blue dresses get tied up into the inferences of other things that I do on the internet, the places and where I shop, the magazines that I may read, the friends that I might have, where they actually determine without me telling them that I'm actually a Black woman who loves blue dresses, who, by the way, may be part of the widening wealth gap because maybe I'm buying too many blue dresses and I need predatory credit card offerings, that then lends itself towards disparate impact. And I think that's really important to hear because I said earlier, I'm not a scientist, I'm not an engineer, and I'm not a computer scientist. I'm a social scientist that understands the relationship between the socio-technical parameters of how we look at these new artificial intelligence spaces. And I'm one that's concerned that we will essentially create the same type of external inequalities that manifest themselves in the external world. Now, some of you may say, well, Dr. Nicole, what do we do about it, right? Because these machine learning algorithms have basically taken over our lives. And what I would suggest are a couple of things, and then I'll wrap up, that I think are particularly important when we begin to think about how to address algorithmic bias. First and foremost, we all have to understand that we come to the table with an inherent set of values, norms, and assumptions that are untreatably biased. Where we grew up, who we are, who our friends are, how we learn, how much money we made, how much we didn't, that all factors into the design. And I think that's a particularly important acknowledgement because when you begin to look at where these algorithms go wrong, oftentimes you find, like in the case of the healthcare algorithm, that the developer had no clue about the discrepancies in investment in healthcare that existed between populations. That same argument could be made for someone who may be trying to do technology for good, who may not understand that a criminal justice algorithm is actually using data from a flawed criminal justice system that over-criminalizes Black men and women and Latina men and women and poor men and women in ways that the data will be reflected in any type of outcome. So I always tell people, first, you got to look yourself in the mirror and acknowledge that you may be bringing those biases and assumptions to the table. I think the second thing that's really important is that we develop the type of models that allow us to approach bias in a very deliberate and strategic way. In my work at Brookings, I'm working on something called an Energy Star rating. And this came about because my dishwasher broke a couple years ago. And I went into a big box store and I was like, I need to buy a dishwasher. And I was looking at the dishwashers with the big yellow sticker because that yellow sticker indicated a couple of things. It indicated how it was tested in, against water consumption and electric consumption, the durability of the plastic, etc. In the new economy, especially in the pandemic, we are now relying upon an online world. And I think it is beholden upon companies as well as developers to understand that it is their job to actually have algorithms which perform effectively in a variety of contexts. And that, to me, friends, is the beginning of a fairness conversation. That yellow sticker identified that that dishwasher was going to work to its standards. And we really need an Energy Star rating that allows us, and they're doing this in Germany, to understand whether or not this algorithm is going to perform around a variety of contexts. I often give people the example of facial recognition technology, which we all kind of know right now does not work well against people with darker skins or poor imagery or lighting. And so I always tell companies, when you think about the performance of your algorithm, obviously it doesn't perform well on me. So I either want some assurance that you're testing it against subjects like me, or you're disclosing where those fallibilities exist. So my Energy Star rating, I've been looking at, for example, what are the technical cadence opportunities to make them better? Are we testing them in different contexts? Are we including training data that is more inclusive? Are we looking at public policy prescriptions that ensure that these products do not violate civil rights law, like housing and employment and financial services? And finally, something that's not often discussed, are we checking back with civil society, with people, to understand whether or not the algorithm performs best and is maximized for them? Ultimately, I think that that's a great model, one that I'm writing about right now, but it's one that actually moves the conversation not towards more regulation, but it suggests that we cannot continue to exist, particularly in sensitive use cases, on a wait and see or break it fast and build it back, because the implications for people are so great. If you foreclose on the creditworthiness through an algorithm on someone's ability to get a loan, trust me, that will stay with that person who is already economically fragile, and it will be harder for them to reverse it because the opaqueness of computer technology today makes it hard for us to even understand how these things work, let alone the layperson. The third thing I would just say is that we need interdisciplinary cooperation. I love me some Eric Rice. He was one of the few people that I met that understood how this issue actually intersects with sociology, political science, economics, social services. And there are not many people who do that. This is not to say that other programs are not at the top of their game when it comes to the science, but science is discrete. And science, particularly in these situations, may not account for the variability of subjects, the flaws in data, and the opportunity for humans to come in and make clear judgment about whether or not there's fairness that's embedded in this model. And that really, my friends, the reason that I share those 3 points goes back to this concept of fairness. If you look at it the way that I'm setting it out in the socio-technical perspective, nothing is fair because everything that we create comes from a biased platform. The things that we can work closer towards are systemic frameworks that at least acknowledge those biases, but also make the determination as to whether or not we think that decision will bring fuel to the fire of decisions that have already over-incarcerated, over-promised, and in some respects underrepresented on the people not necessarily factored in our decision-making. And so as I actually begin to wrap this up, I always tell folks when I think about even my own case, the challenge that we have now with algorithmic bias and fairness is one that simply replicates the society in which we live. Computers don't bias, my friends, people do. But the opportunity to get closer to fairness is to have these interdisciplinary cohorts that begin to understand not just responsible AI, but ethical, lawful, and inclusive AI in ways that I think we're currently not having those conversations. And more importantly, in addition to actually having these conversations about fairness, you can't have it when you have only homogenous people with a seat at the table. It's not only important to have people by disciplines, but having people with the lived experiences of what we're trying to actually address in those models also matters. I know one thing as I wrap up, I struggle, and sometimes I'm quite exhausted because there's a shortage of women of color working in this space. And it's no secret that for some of those women of color who worked in high offices and very esteemed companies, they're no longer there. And we have to continuously make in our minds or tell ourselves, how do we reconcile these other things, these egregious actions on the outside to ensure that our models on the inside do not suffer the possibility of expanding and replicating and sustaining those systemic inequalities. And so I would just leave it for all of you here. As we have these conversations, it's first most important to say, is it that significant that we automate something that is significantly unfair? And two, do we have the right people at the table? And three, are we also developing models that surpass our wildest imagination to potentially help us hone in some of the inequalities that we've already experienced and seen? So I'm going to stop there. You can find me, Dr. Nicole Turner-Lee, on Twitter at Dr. Turner-Lee. My book is coming out, but we write a lot at Brookings on algorithms from the governance side to the bias side, and then just a host of intersectionalities with privacy and race and social justice. So just go to Brookings. You'll find me there, and you'll find also a stream of work under the link AI that will actually talk about those things. So I think I'm going to stop because I think there's some questions that are here in the audience, but I'm just so honored and blessed to be here today to talk to all of you.
Thank you so much, Nicole. That was wonderful. So
it's so weird talking in a Zoom, so hopefully it
yeah,
was.
it never gets easier, does it? But we do have some questions in the chat. So Dan Ho is asking, or thanking you so much for sharing this important perspective. And he's curious how you think about audit standards for rating systems for AI. For instance, the Government Accountability Office did an audit of the Energy Star rating system in 2010 and concluded that it was vulnerable to fraud and abuse as there was little verification. So he's curious what you think is necessary for such a meaningful rating system.
Oh, I love that question. And thank you, Dan. You gave me more stuff to go look at because I'm writing this for a book chapter right now. You know, I think, and how I pose this Energy Star rating, again, thinking about, both the GAO standards as well as the FTC enforcement, is we need something that starts on the machine learning economy after NIST, who is the government agency that's responsible for sort of sharing the standards around what makes, more responsible algorithms or AI in general. And so I think it's important because I do like this question of vulnerability. And I think we're going to continue to see vulnerability in an internet ecology, which is still very opaque. I mean, no decision is ever really made with two people sitting side by side, right? There are no adverse reactions. If an algorithm like Credit Karma determines whether or not you're credit worthy, you just can't take that into a car dealer, right? But in many respects, these algorithms are just optimizing what we put out in the public domain. And given the lack of federal privacy legislation, it's sort of a wild, wild west. So I do suggest, as part of this Energy Star rating under the technical cadence side and the policy side, that we think about where are there auditing prescriptions that would make it easier for these algorithms to be explainable. Clearly, the black box is unknown to anybody, right? And the argument is often made that the input, which is the model, is proprietary, and the output, which is the decision, is legal. I always find that policymakers on one side, and developers on the other. Somewhere in the middle, which is this iterative organic process of what the algorithm ultimately becomes, we do need to be able to trace whether or not there are some use of proxies that may actually violate some of the sectoral laws, like the Fair Housing Act or Banking Act. Or are there areas where the algorithm has gone awry, where it's actually creating the type of disparate impact, like kicking out women in an interview versus men? And so, as I put it with folks, there are a lot of really good people working on that side of the equation. But when we get to that side of the equation, I sort of make the argument in the book, a lot of things have already happened in that algorithm. So what I'm trying to do is figure out when it leaves NIST sort of recognition here in the United States of its performance, who is actually checking that? And that's why I think, Dan, to your question, though there may be vulnerability and fraud, as we see, for example, in consumer rating systems on commercial products, there may be a value for people to be able to attest to the validity of the performance of that algorithm. I would rather that happen, or maybe public policy interventions like regulatory sandboxes, where you can sort of co-evolve and co-develop if there's high risk of bias, versus allowing this to be unchecked. And so I would love to talk more about this, like I told you where you could find me, but I think you're right on, because I think that there's a belief that you have to put more enforcement on this, which in some respects actually may limit our ability to correct it. I'll just say this last thing. In facial recognition, for example, there's a lot of calls for bans. And I'm all for bans in terms of the malfeasance of law enforcement to use it in a way that over-criminalizes. But that doesn't mean I don't want you to make it better, because the technology itself seeps into other applications. So if we just ban it and we tell companies not to make it, and it seeps into how I open my phone or how my emergency system identifies me, it's still not optimized for me. And so there's this, counter that we have to keep making on how do we continue the technological innovation while at the same time putting in the right gap stops to get at some of those blind spots. And I explain this in this chapter that I'm writing as part of this book for the Oxford University Press, but it's real interesting because I just find that there's always a push against regulation, which addresses fraud, while at the same time, there should be a push towards, again, being more inclusive, more lawful, and more credible in the performance of those algorithms.
All right, thank you so much, Nicole. Thank you for all of your plugs and for all of the interesting things that we must certainly be keeping in mind, right, as we're designing and moving forward with our AI solutions that hopefully are not as harmful as others that we've seen. Thank you so much.
Thank you.
All right, and moving along, we will be hearing from our next speaker, who I believe will be the last keynote speaker of our morning session today. So thank you, Ty, for moving Karen over. So I have the pleasure of introducing Karen Smilowitz. So Dr. Karen Smilowitz is the James N. and Margie M. Krebs Professor in Industrial Engineering and Management Science at Northwestern University, with a joint appointment in the Operations Group at the Kellogg School of Management. Dr. Smilowitz is an expert in modeling and solution approaches for logistics and transportation systems in both commercial and nonprofit applications, working with transportation providers, logistics specialists, and a range of nonprofit organizations. She is the founder of the Northwestern Initiative on Humanitarian and Nonprofit Logistics. She has been instrumental in promoting the use of OR within the humanitarian and nonprofit sectors through the Woodrow Wilson International Center for Scholars, the American Association for the Advancement of Science, and the National Academy of Engineering. Dr. Smilowitz is editor-in-chief of Transportation Science and has received the award for the advancement of women in OR and MS from Informs, and has led the winning team in the Informs Innovative Applications of Analytics Award. Welcome.
Thank you very much. Can you hear me and see my screen? We're off to a good start. Excellent. Well, thank you. And I'm so glad I'm going after the speakers, because I was taking notes about all the ways that they helped me streamline my talk. So hopefully I'll get us back on time. But if I'm going way over, Phoebe, just kind of start waving. But I'm happy to talk today about how we can think about using technology for more equitable access to learning, and kind of a look back and a look where we are in the future. Let me also take a moment to thank all of my collaborators. I want to call out Nicole Pinkard, you can see up on the right. So in Dan's presentation, I'm telling you, there's so many ways these talks set up my talk. Dan had a picture of Stanford and then a bridge to policy. This is my collaborator, Nicole Pinkard, who's wearing a Stanford sweatshirt because as a Cal grad, she knows that drives me nuts. But she's literally standing on a bridge between the 5th and 6th wards in Evanston. And so I'm going to talk a lot about the map of Evanston, which is the city where Northwestern is located, and about equitable access to school. And also kind of going off of Nicole Turner-Lee, who just spoke, her point about interdisciplinary collaborations. I want to thank all of my collaborators here. Oops, sorry, I went in the wrong direction. So I wanted to think about, and again, this I think is ways in which this talk will really build off of the previous talks that you've seen. But thinking about in the past, and I'm going to talk about work from the 60s and the 70s, where really technology was thought to provide a solution to societal problems, to moving into ways that we think about fostering conversation, thinking about visualizing inequities. So again, this is kind of, we're really building off of what some of the other speakers talked about, letting us think about what is possible in terms of correcting those inequalities. And then how do we work with communities? So again, many of the ideas that you've seen before, but specifically, I'm going to focus on the question of optimization modeling for school redistricting. So this is Evanston, Illinois. Northwestern is kind of off to the side where it looks like someone's sitting over there on Lake Michigan. It's a lot, but this is our school district. So I'm going to talk about some of the work that we're doing. But before I go into the present and talk about what we're doing, I want to go back. Some of you who've seen me give this talk before have seen my very brief timeline of school desegregation in the United States. I'm going to make it even briefer today because I really want you to focus on what is in the middle. So in 1954, in Brown versus Board of Education, this is what ended de jure segregation. So this is Jim Crow laws, segregation of schools by law. Where operations research really came into the picture was in the 60s and 70s, when school districts really faced the question of how were they going to desegregate. And Swan versus Charlotte Mecklenburg is the first case that really talked about busing as a mechanism to promote integration. And so that's kind of where my talk is going to focus today. So again, looking back at that time in the 50s, 60s, 70s, what was happening in the operations research community was getting really good at linear programming. And so one of the problems that was studied and very efficiently solved at the time is the transportation problem. So for those of you who are not familiar with the transportation problem, I have a set of sources, some material on one side, and I have a set of destinations or demand on the other side. And so at its core, the transportation problem is simply, how do I assign sources to destinations such that I minimize the cost? So Dij is my distance from source I to destination J. And now I have to determine these X variables, Xij, from the source to the sink. So we have a way of matching supply and demand. And I say we, but I was not there in the 50s and 60s. But the research community said, okay, well, now that these districts are looking at the question about how to desegregate schools, if we're thinking about assigning to students to schools, and I want to thank Patrick and Sunmay for talking about the assignment problem earlier, they started modeling this as a linear program. And I'll talk a minute about why even the fact that it's a linear program is problematic. But thinking about, okay, so on one side we have the students, and models typically didn't consider individual students, but rather some neighborhood, some geographic region. Due to computational power at the time, these tended to be fairly large, which in and of itself is problematic. So on one side, you have these geographic units, I'll call them blocks, and on the other side, you have schools. And so the decision variable now is assigning these blocks to schools. What you'll see added to these X variables is another index K for the race of the students. So looking at how do we assign students to schools so that schools are desegregated to be in line with the racial composition of communities. So this is kind of what's happening in the modeling community. I'm going to show very briefly, it's not meant to be a talk on mathematical modeling, but I do think it's important to think about the way in which models promote decisions. And Nicole talked about this really nicely in her talk when she said, you know, computers don't have biases, people do. And so you look at a mathematical model, and it's important to kind of step back and think about what biases are in place in designing this model. So this paper from 1968 is kind of the what's called the kernel problem in school redistricting. And so it looks a lot like the transportation problem. The objective function is to minimize distance, just as it is in the transportation problem. So as you assign students to school, you minimize this distance. I thought that Patrick and Sadmay really set up the different objective functions really nicely. And depending on how we're doing on time at the end, we can talk about that. You've got a capacity on the school assignments, you need to assign all of the students. And then the way that these models were different from the transportation problem is these racial balance constraints. So looking at the resulting assignments, how do we think about achieving the goals of desegregation? So one of the really interesting papers that came out around this time in the 70s was a paper by Stinson and Thompson that said, well, these papers are fundamentally flawed. And it's kind of, again, getting back to that point that Nicole made, that desegregation is a spatial concept. Yes, we can look at how students are assigned to school, but that doesn't necessarily integrate schools. They're not the same thing. And so what they did in this paper is they evaluated the papers at the time within the operations research community that was looking at school desegregation and looked at which papers thought of this simply as a desegregation problem versus which really went further and thought about an integration problem, thought about what biases are involved in the models, what ways are we involving the entire community in making decisions rather than just simply prescribing a solution. And what they put forth as an example, as a wider perspective, is the way that Berkeley implemented two-way busing in their school desegregation. And so there's two things I want to highlight from a modeling perspective. One was they moved from this xijk variable to an xij. And again, this is where you think about how do the guiding principles of a community guide or inform the way you model the problem. And so this idea that children of the same age in the same neighborhood should go to the same school. And that's really, if you look at models today, you don't see it. There's no index by K, right? It is really thinking about where students live and where they go to school. I think the most innovative that they did as well is two-way busing, right? So again, the principle here was the burden of desegregating schools should not be placed solely on one racial group. The preponderance of desegregation plans at the time were one-way busing, where schools in predominantly Black communities were closed and students were bused to schools in white communities. What was done in Berkeley is schools were kept open. They were divided by grade level. So at one point in your K through 6 experience, you're taking the bus, whether it be K through 3 or 4 through 6. On the flip side, in Evanston in the 60s, one-way busing was the plan for school desegregation. And so you can see in the purple here, I've highlighted what is the 5th ward. And actually, if you kind of go up to that point in that polygon at the top, that is where Nicole was standing on the bridge. And so Foster School was closed. And if you look at the resulting map, not because they opened up a bunch of tiny little schools, these very small polygons in the 5th ward where the arrow points is not the polygon surrounding schools. In fact, these are busing zones. And so if you looked at, it's very hard to see in the figure, this is an old image, there are letters associated, and these are the schools to which students were bused. So now you're doing two things to the neighborhood in the 5th ward. One, you're closing the school that creates a sense of community, and then you're further breaking up the community by taking the students and assigning them to many different schools. In 2021, where we are right now, that is still the solution. Now, there are not as many polygons, but there is no school in the 5th ward. So you'll see a rectangle in the middle that says Willard. That's not where Willard is. Willard is up here in the 6th ward. And this is, if you think of the 5th ward as a triangle in the middle, the students are assigned to many schools, and there is no school in the 5th ward. What is really exciting right now is with our new superintendent and the new administration, there is a push to address that. There's been pushes in the past, but this is Sarita Smith, who is the new director of student assignment, which is a position that did not exist before. And this is Sarita last month presenting this plan at the school board, which is her call to action. And I think what's really important in the call to action is the way she talks about all students have the right to a high quality education in their neighborhood, and not just high quality, but the appropriate programming. So whether it be English language learning programs, African-centered curriculum, but making sure that within neighborhoods we have schools, and we have schools with appropriate programming. So where we come into this at Northwestern is, and this gets to this point of view of technology really helping to visualize inequalities. And I thought Dan showed some really neat visualizations as well. This at the top is one of our visualizations that was shown at that meeting where Sarita Smith launched the committee. So you can see that the 5th ward, they're assigned to many schools, but it goes deeper than that. And what has happened as a result, so the students in the fifth ward are bused to all of the schools. They're not necessarily, the schools to which they're assigned don't necessarily have the appropriate programming. And so when we looked at this figure, and it's a little bit hard to see because it's small, the size, and this is actually in this figure looking at inequity by income level, not by race, which is another issue we can discuss if we have time. But the height of the bars looks at the number of free and reduced lunch students in each school by each ward. So the x-axis, and one axis is the ward where the students live, and the other axis is the school the students attend. Now they're colored red and green. I don't mean to imply that that high numbers of free and reduced lunch students are good, but that the district is meeting the needs by having schools in those communities. When you see really high bars, this is a high number of free and reduced lunch students who are attending a school outside of the ward where they live. And so it's kind of hard to see here, but the line going back where you see a lot of high bars, this is the fifth ward. And then to the right, you see the sixth and seventh wards where there are barely any. So up in North Evanston, where you see 4 schools, that's the 6th and 7th ward, which are the wealthiest wards in our district, and there's 4 schools. And then down to the 5th ward, there is not a school. And so that's kind of where this work comes in. And then if I have a few more minutes here, I want to show what we're developing for the district, which
when
is
the tool loads, we are greeted with a priorities form. This form helps us create a mock layout of the school assignment blocks. Here, you can give a name for your solution and prioritize different objectives by indicating low, medium, or high, and setting a limit to how many students will be reassigned to a different school. Here, I will name the solution Test 1, give it high priority for distance traveled, medium for the number of students bused, and medium for the number of Title I schools. I would also like no more than 10% of students to be reassigned. After clicking Submit, you can immediately see the block assignments on the left for this test solution. The color legend to the right of that indicates the school name, and below that is a map toggles box to display the outlines and labels you want. The solution box on the right shows the objective weights you had just inputted. You can also click on View Constraints to view additional information on different constraint measures. So in addition to the map, we use different graphs and charts to visualize other data that might be helpful in making decisions or simply showing comparisons. The chart below the solutions box compares the number of TWE English and TWE Spanish students in TWE schools. The chart below that shows how many students qualify for free and reduced lunch at each school. This chart shows school enrollment percentages. The top graph here compares the 3 objectives of the current school assignments to our test solutions. Along with the map, these graphs are all dynamic, meaning they will correlate with the inputted test solution. You can always add another solution by clicking the Change Solution button and clicking New Solution.
In the interest of time, I think you kind of get the gist of what our tool does. I'm going to just kind of sum up where we are. So this is kind of the tool that we've been building over the last 2 years with the school district. Now what's really exciting is the community comes into play. And so this is the timeline for the student assignment committee that Sarita Smith is leading. And so we're going to be able to go to the community with this tool, both to visualize the current solution, but now to get their feedback. What objectives do we want to think about in the solutions? How do we think about trade-offs between neighborhood schools and diverse schools? What does that mean in terms of the burden of transportation? So it's been a really great experience. It's a really neat opportunity to think about how do we now go back to the model with our feedback from the community. And like I said, with the new administration, it's just really been neat to see all of this go forward. So with that, I'm going to answer any questions that you might have.
Awesome. Thank you, Karen, so much. Yeah, I have a question. So you said if we have time, which I think we do, about the different objective functions and what kind of pops up there. So I would be very, selfishly again, I would be very interested in finding out more about that.
Yeah, that's been really neat because it's so interesting because this project started with a prior administration and now there's a new administration. So even just with the change of administration, the objectives have changed. Like you saw, actually, I'm going to answer your question on going to constraints rather than objectives first, because we started with, you see like 5 or 10% reassignment. I think that's really changing now in terms of how many students you can minimize. You know, it started with, if we wanted to get rid of the Willard Island, what's the fewest changes? And now it's really thinking about how do you think more generally about the distance students travel to school. How do you have access to a neighborhood school? So sometimes, if you did just an aggregate distance, then as long as some students are close to school, that's fine. But in fact, you want to think about which students are close to school. So I think a lot of the ways in which, and again, I want to thank Patrick and Senmai for setting this up, but thinking not just about measures in the aggregate, but thinking about these min-max objective functions, but then lexicographical min-max. So you can think about what does it mean to to minimize the number of students that don't have a school in walking distance, I think is a really good one, to really kind of set what do we think, and this is where I think Sarita's call to action is really exciting, because you can find a model that really is built on her principle. Her principle is all students have a right to a neighborhood school. So shouldn't the objective function be, how do we manage to get all students the right to, not even like the number of students who have right to a neighborhood school, but all students should. So it's really interesting to think about the ways in which we can play around with that. I think the objective functions also highlight, a lot of people in Evanston will say, well, if we have a fifth ward school, then the schools won't be diverse anymore. But what the tool does is say, well, let's look at what is currently the situation. Are you okay with that? Yes, our schools are diverse and we hit the 60% guideline that the district has set, but what does that mean in terms of how far you travel to school, and whether or not race or income is a significant factor in determining how far you travel to school? And again, are you okay with that? So did I answer your question?
Yes, thank you. And more so, yeah, I think the tool is, a really great way of just getting people to kind of come to terms with the reality. I think that's a really awesome thing to do. So thank you for sharing. Yes, and I think in the interest of time, unfortunately, we'll have to keep moving forward. But thank you so much, Karen, for your wonderful talk.
Yeah, we will have Karen as well in our seminar next week, I believe. So if you want to learn more and ask more questions, please join us there.
That was my plan. I was going to do the high level today, and then next week we'll go into details.
Fantastic. We have the reverse tomorrow, where we had a speaker come in and give us a high level, a big detailed one last month, and then it's going to be high level tomorrow. So we like to keep our friends close.
Awesome.
So thank you. So in the interest of time, I think maybe what we should do, since this is a virtual event and we can't really see folks when they get up to leave and use the restroom or grab a cup of coffee, maybe we'll just take a brief minute or so break to allow the three lightning talk speakers to get logged in, bumped up to panelists, get them access to co-hosting capacity so they can share their slides. And once folks are kind of in position, I'll begin doing some introductions. We have this next section will be a little bit different format. We're going to have very quick, but hopefully very interesting and thought-provoking talks that are going to be 5 minutes long. And then we will have a larger discussion for all three of our speakers after the 15 minutes of talking that's going to happen. So it looks like we have everyone in. Fantastic. So I will begin with my introductions with Dr. Erica Van Buren, who serves as the Chief Innovation Officer for First Place for Youth, where she leads the evaluation, learning, and national expansion strategy for scaling First Place's influence and impact in service to older foster youth across the country. She crafts and implements the internal and external evaluation agenda for the agency, works closely with program leadership to innovate and roll out best and evidence-based practice strategies. And even though it's not in her thing, I'm going to say, and does some of the coolest real-world implementation work that I've seen that uses AI and evaluation science. So, Erica, if you're ready, then I will cede the floor to you.
I am. Thank you so much for the introduction, Eric. It's a pleasure to be here. I think Phoebe's going to be my Vanna White for this panel, so she's going to share my deck. But I can start by talking to you a little bit about where I work. I'm the Chief Innovation Officer for a national organization called First Place for Youth. And we are one of the largest service and advocacy organizations for youth in extended foster care. And I'd like to talk to you today about a practitioner-focused decision support tool that's on its second generation that we've developed. It's called the Youth Success Roadmap Tool. So we can go to that next slide. Let me tell you a little bit about the context of extended foster care and what we know. Young people aging out of foster care experience a myriad of disparities and deleterious outcomes relative to their same age peers. The stories of foster youth being released from care on their 18th birthday with no place to go and their belongings in trash bags has been an all too common story for this population of youth. The good news is that in recent years, the largest policy study on the impact of extended foster care has documented that each additional year that young people spend in care from ages 17 to 21 significantly decreases the likelihood of experiencing a range of negative outcomes and an increase in the likelihood of activities that promote self-sufficiency, including employment retention and post-secondary enrollment, which First Place for Youth is particularly interested in. Although these results tell us that extended foster care is at least partially achieving its goal, the same research has also highlighted that participation in the extended foster care is not moving the needle as successfully in helping young people to obtain college and vocational degrees or in obtaining meaningful increases in earned income. Next slide. So First Place actually took this as a call to action. Leveraging several years of our own administrative and follow-up data on youth, and we collect a lot of data, the youth that we've served in our core housing, employment, and education program, which we call the My First Place program. This is an extended foster care placement that we offer. We partnered with Peter York and his team at BCT Partners to conduct a predictive modeling process to build a web-based decision support tool for our direct service providers and managers to use on behalf of and with their youth to help support high precision programming in the development of action plans, the selection of interventions, and decisions about transition needs and timelines with their individual youth, with the goal of helping all of our young people leave our program with living wage employment. Next slide. So the modeling process itself first identified 10 different participant types of young people who had different likelihoods of success in achieving living wage employment at the front door of our program without any services from us. This was based on the biggest predictors of this result, which were the number of prior foster care placements, the age at entry to foster care, and how many group homes a young person had lived in prior to coming to First Place. This is well documented as predictors of a lot of different outcomes for young people in this particular population group. Pete and his team then trained machine learning algorithms to find all the different services that have been tried by and with youth over the past several years and the progress made toward key measurable milestones for similar youth within their participant types. Matching within participant types and looking for what services, interventions, and milestones contributed most to causing the achievement of a living wage created naturally occurring quasi-experimental treatment and counterfactual conditions by which to evaluate the impact of My First Place service components on individual youth. Next slide. So there are several key features of the tool that vary by participant type. First, the high impact goals identified by the modeling process reflect the in-program milestones that are most predictive of the result at exit and account for up to 80 to 99% of what it takes to achieve living wage for individual youth. Likewise, the high impact services account for 62 to 92% of what it takes to achieve the high impact goals for individual youth. The modeling also revealed two distinct stages of program for youth that have different service and goal recommendations. The services and goals in stage 1, which we call the entry and stabilization stage, provide stability for youth and prepare them for participation in education and employment activities. While stage 2, that what we call the pathway to living wage, provides individualized services and goals that help each participant engage in what works on the trajectory to obtaining living wage employment by program exit. Next slide. Okay, so what does it look like? There's multiple dashboards, but I'm showing you a screen grab of the youth progress dashboard within the tool, which tells practitioners which stage and participant group a young person is in, how many weeks they have left in program, what the highest priority services and goals are for that individual youth, and their progress towards achieving them. Selecting an individual service or goal will then take the practitioners to a document with definitions and best practice guidelines for implementing that specific service or achieving that particular milestone. The same data is available in other dashboards that at the caseload and site level as well, and all dashboards update daily from our performance management system. This was actually co-designed with young people and with staff. Next slide. So what does the way ahead look like for us? We've actually released a research and policy brief about the Youth Roadmap tool methods and results, and we hope you will read it. I think we're going to put that link in the chat. And we're going to be conducting a series of webinars on the results and the policy and practice implementations, because the results that come out of the use of the YRT will be used to that end. We will continue to evaluate the effectiveness of the tool, and we will be looking to scale. And ultimately, we hope to establish a learning hub for diverse child welfare stakeholders to build the sector and the use of evidence emerging from the tool to drive momentum for systems change. And my last slide is my thank you slide. That's all I've got.
All right, thank you. Our next speaker, and just to remind folks, please put your questions to any of the panelists into the chat or the question and answer, and we'll take them all at the end of this session. The next speaker is Dr. Sina Fazalpour, who is a Social Sciences and Humanities Research Council postdoctoral fellow in the Department of Philosophy at Carnegie Mellon University with a secondary affiliation with the Machine Learning Department. His primary research focuses on issues of justice, reliability, and accountability in predictive and decision-making algorithms. So it's a nice follow-up to what we just heard. He also works on understanding the concepts and consequences of diversity concepts and consequences of diversity in social groups and networks. If you are ready, you can take it away. Sina, we can't hear you.
Yes.
There we go. Perfect.
Right. Thanks for having me, and I enjoyed the talk so far. So let's quickly get into this. So my talk is about kind of recent worries about algorithmic bias and algorithmic injustice, particularly in allocation setting. So a dominant line of research that you might have seen in the literature tries to orient algorithmic design in light of these worries towards ideals of fairness and justice. And typically the way that this is done is by constructing and enforcing some fairness measures, which are supposed to be formalizations of normative ideals that we might have. Now, this line of research has faced what we might call an indeterminacy challenge, in the sense that there are disagreements between what is the right measure of fairness. In certain cases, they come apart from our intuitions about what the right measure should be. And in certain other cases, you might have seen impossibility results that show that many of these measures cannot be jointly satisfied unless we are under highly contrived situations. So in light of this type of disagreements and indeterminacy, one line of philosophical work has tried to clarify the normative underpinnings of these measures. What is it actually that they try to formalize? And the hope here is that they can either dissolve or resolve this type of indeterminacy challenge. That is, either they might say this measure, when two measures are in conflict with each other, one of them actually is irrelevant to questions of fairness and justice. Or if there are value tensions, they can at least explicitly tell us what is the value underpinning some measure so that we can make informed decisions about our choices. What I want to focus on today, though, has to do, is kind of a bit more broad. I abstract away from the question of which particular fairness measure we have to choose. And I want to ask about the general mode of moral appraisal, that is evaluation of a system, as well as prescription about what to do about the problems in the system that underpins these current practices that use these fairness measures. And if there are limitations, how should we address it? So I make two sets of claims. One is that despite differences in a specific choice of fairness measure, current practices tend to involve the same mode of moral appraisal, the same pattern of normative reasoning, if you will. And in this pattern, our evaluations and interventions are typically justified by reference to some ideally just targeted state that we would want to achieve. So these targeted states are the object of moral appraisal in these frameworks. But this is systematically insufficient for a number of reasons. And what I will focus on here is the challenges that arise when we consider and take seriously the deployment dynamics. So we need serious alternative frameworks and tools, methodological tools. So I suggest two alternatives quickly. One is that we take procedures as objects of moral appraisal, the other one, dynamic trajectories. So what is this current, the framework that is the current approaches are based on? As I said, they take target states as direct objects of moral appraisal. So we start with some ideal target state. We try to specify it in terms of a fairness measure. And they play two types of role. One is evaluative role, where they help us identify discrepancies between the actual performance of a predictive model and what we think that model should behave like. So the ideal target state as specified by a fairness metric, what we ought to observe. And after this, they also play a prescriptive function in the sense that they justify our supposed fairness enhancing or justice inducing interventions that might kind of focus on pre-processing, objective design, or post-processing in terms of the ability of those interventions to close the detected gap between the actual and the ideal. Notice that the role of normative reasoning here is constrained to the choice of ideal target state and fairness metric. And the interventions that are designed, typically in practice, to proactively enforce this target state, they focus on the predictive model. Either it's immediate input, the model itself is objective, or the objective for which it was optimized, or its immediate output. And they test this in light of a static test data set, abstracting away from dynamics of deployment. But of course, what we care about is how models perform in the real world, not in relation to a test data set. When we go to the real world, we face problems in complex social systems. So we have knowledge gaps in many decisions that we make. We don't get immediate feedback about whether our decision was correct or not. So the feedback is delayed. In certain other cases, we don't have access to counterfactual outcomes of our decision, whether somebody that we denied, to whom we denied the loan would actually fail to repay it, right? So we have limited observability. Also, we have interactive effects in social dynamics, and some of the previous talks have highlighted some of these things. So we have couplings between different institutions, we have strategic behavior by decision subjects, we have partial compliance by other decision makers, and all of these things can result in a kind of decoupling or separation between the actual effects of our intervention and the professed aim for which those interventions were designed. And typically, given the amount of assumptions and disagreements that are involved in modeling the real world, we cannot really say that, okay, let's define our target as in terms of the broader system, because that would make our interventions extremely fragile. So the question is, given that even if we resolve the first determinacy about what is the right choice of metric or what is the right target state, we cannot actually reliably assess whether and how often, how frequently our policies designed in advance will bring about a target state. So what can we do about this? This is, of course, not a problem that is foreign to many people. Many different disciplines deal with it. One line of research in political science and philosophy, like, for instance, the work of Jan Elster. Elster suggests that given this second order indeterminacy that has to do with the dynamics of deployment, epistemic humility requires that we scale back our ambition. We should focus on the procedure. Good decision-making involves making the procedure as good as we can, not justifying it with respect to some outcome that we might or might not actually achieve. So we focus on that and let the chips fall where they may when the outcomes are concerned. Now, this also has a benefit in the context of fair machine learning in the sense that it promotes, I think, a much needed attention to biases in problem formulation, in operationalizations, construct validity, and measurement. But it also has limitation in the sense that dynamics of deployments here are kind of only negatively impacting our moral appraisal. Basically, Elster is just telling us, given how difficult this is, we should just focus on the procedure and just neglect these dynamics. So in our current work, we are suggesting a further alternative that we think is actually, you can see it in many other fields. And the idea here is that instead of just taking the targeted state or just the procedure as the object of moral appraisal, we should take dynamic trajectories. That is how social systems evolve in response to our interventions, which might be not just one intervention, but a series of interventions into account. When we consider that, then dynamics of deployment can positively inform our moral appraisal. And here, the appropriate tools are not just the typical tools of machine learning, but tools involving foresight analysis, participatory design, tools of complex systems like agent-based modeling, and tools of safety and reliability engineering. And I think this is useful because it helps us identify alternative meaningful endpoints and potential externalities of our intervention. So in the previous talk, I think by Karen, we saw some of these things. When we use simulations to identify these things, typically they give us qualitative insight, right? And they're typically too coarse-grained to allow us to proactively fine-tune our intervention or our model to achieve them. But if we take the trajectory into account, these even coarse-grained and qualitative insights can be extremely useful for kind of real-world regular monitoring of our intervention. And it allows us to incorporate typical trade-offs that are known in sequential decision-making and complex systems. So explore, exploit, and trade-offs involving robustness. So I think this is a promising way of thinking about how these things work. Thank you.
Well, thank you. And we're going to have probably a shorter time for question and answer so that we can catch up a little bit on time, but we certainly will have time to finish out all the speakers for sure. So our third speaker for this session is Vinod Prabhakaran, and Vinod is a research scientist in the ethical AI team in Google Research. His research focuses on cross-cultural considerations in AI fairness and ethical inquiries. Prior to Google, he was a postdoctoral researcher at Stanford University and obtained his PhD in computer science from Columbia University. And I'm a little bit familiar with some of this older research where he did some pretty crazy race bias detection work with police, in fact, identifying and addressing large-scale societal issues such as racial disparities in policing, for example. So Vinod, welcome, and the floor is yours.
Thanks, Eric, for that great introduction. Let me start by sharing the screen. Okay. Are you able to see my screen?
Yes.
Awesome. All right. Thanks for that great introduction, Eric. And some of that crazy work I'm continuing to do, doing in collaboration with Stanford, but today I'm not going to be talking about that. So today I'll be talking about non-portability of algorithmic fairness across geocultural contexts. This is work done jointly with colleagues at Google, Nitya Sambashivan, who is an HCI researcher who led most of the work, Erin Arnesen, Ben Hutchinson, and Tulsi Doshi. And we all come at this project from very different disciplinary backgrounds. Also, we are situated in different parts of the pipeline, or like the machine learning research and development pipeline. And thanks to Dr. Nicole Turner-Lee, as well as like the other panelists who spoke before me, who beautifully set up the stage for my talk. So I could remove one slide from my talk. While AI has seen a lot of numerous beneficial applications in society in recent years, it has also been pointed out like there's a lot of fairness issues, or algorithmic fairness issues, that might capture various societal biases, as well as propagate and sometimes amplify those biases in society. And this could happen even in the most well-intentioned interventions, per se. And to take an example of like, fairness failures in facial recognition technologies, like were first surfaced like 4, 5, 6 years ago. And then there was this paper in 2018 called Gender Shades, which sort of like got a lot of attention to the problem of like how disparate the performance of facial recognition algorithms are on people with darker skin tones. And over the last couple of years, we have seen a lot of like impact in in terms of like pausing sort of like large scale rollouts of facial recognition software, as well as like bans instituted by various jurisdictions. And regardless of how you think about like these outcomes, like the success that it has seen in this topic comes from a lot of painstaking effort by activists and researchers and developers in order to see these effects. But it also is enabled by a lot of infrastructural ecosystem factors, such as the ecosystem factors that we take for granted, such as the decades worth of scientific empiricism on proxies and scales for subgroups. There's a lot of public data sets that one could look into, public APIs, Freedom of Information Acts to analyze model outcomes, a fairly responsive AI research or industry to bias when people report bias in their models, as well as like government representatives glued into policy, regulation, and accountability in tech. Also importantly, an active media that systematically scrutinizes and reports on downstream impacts of AI. And these are factors that we often take for granted, but are often not present or are flawed in many other geocultural contexts. And to make that a little bit more clearer, conventional algorithmic fairness research is premised on the West, based on Western sort of assumptions that actually hold true in the Western societies. It is reflected in the structural injustices that we often focus on, such as race and gender, both important things to focus on, but like that's what most of the work is done on. Data sets such as ImageNet and WordNet that are situated largely within the Western society or reflecting the Western society. Measurement scales such as Fitzpatrick scale and derives a lot from like legal systems such as like legal frameworks such as civil rights laws and Enlightenment ideals, like values drawn from Enlightenment ideas. Troublingly, these things are being adopted into countries in the global South, such as India, Tunisia, Mexico, and Uruguay right away. And so the questions that we asked were, how portable are the assumptions of conventional algorithmic fairness to non-Western geocultural contexts? And could fairness have a structurally different meaning and manifestation in non-Western contexts? And could successful fairness interventions in the West be potentially counterproductive elsewhere? To answer this question, we focused on India, which is the world's largest democracy, multi-ethnic, multilingual, post-colonial nation, and the world's second largest internet-using population. Despite high-stakes AI interventions and deployments, there is no substantial work on responsible AI or fairness-related work in policy or research side in the technical side. In this project, we used a combination of expert interviews with Indian scholars working with marginalized group across law, journalism, science and technology studies, political science, and so on. And as well as an analysis of emerging algorithmic deployments in India over the last 11 years. Sorry for my cat. And what we found is that one of the high-level findings is that the distance between models and disempowered communities in India, who we hope to serve better, is really large in the case of India and many communities in the global South, via technical distance, temporal distance, physical distance, social distance, and ethical distance. And these distances needs to be sort of remediated in order to have meaningful fairness. So focusing purely on models and data fairness might actually backfire in contexts that don't share or that are in these other geocultural contexts. I'll go through very quickly like some of the highlights and then conclude. So for data and model distortions, there's a whole lot of missing data and oppressed communities in India that do not come into consideration in like a lot of fairness work, and those patterns differ from how they manifest in data compared to like West. There's also unique device usage patterns in India, such as shared devices usage in households, usually by female members of the households. There's also proxy implementations that work in the West may not translate readily to the Indian context. For instance, a zip code would not really capture sort of like socioeconomic class the way it happens in the West. Also, there are Indic models of fairness and justice that already exist that fairness interventions should tackle. And we lay out like a large sort of like set of like different axes of injustices that are relevant to the Indian context as well in the paper. Going to the next thing, the double standards in the Indian MO, which is one of the things that came up in our interviews was that India or in these kind of markets are perceived as a bottom billion data subjects. Like usually we talk about like next billion data subjects, but in effect, in practice, it end up being like at the bottom billion data subjects serving as petri dishes for intrusive models. They are
Oh, looks like Vinod has frozen for a moment. My hope is that he will return shortly. Have we lost him entirely, perhaps? Okay, well, I guess in the interest of time, perhaps we can let him come back and give a concluding remark or two if he has them. But I'd love to open things up to questions. I know that we're a little bit behind schedule, but I'd still love to be able to open questions. I'm looking to see if there are any. Well, since there aren't, perhaps then I will ask a question that is placed to both, really, Erica, you and Sina both. I mean, which is, as you're thinking about, fairness in systems, and I know that, Sina, you're thinking about them, more in this ethical constraint, and, Erica, you're probably thinking about them more in a practical sense. But, do you see, I guess for Erica, like, do you see yourself as thinking through the process of these dynamics, or are you mostly focused on outcomes? And conversely, I would ask Sina to think about what he saw from Erica with the predictive modeling that she was doing, and whether or not there's room for the kind of process that you're thinking about there.
Yeah, I mean, it's a great question. I think we developed our tool as an equity tool based on a system, using a systems lens to understand how could we create more individualized approaches that are fairer in helping young people to achieve the same outcome, based on the fact that extended foster care is a universal policy. It's not, and so meaning it's based on age eligibility, and young people coming into the system who have the greatest amount of need oftentimes are the ones who get the smallest amount of support and time in the system, and the system is structured to do that because of the fact that it's not one size fits all, but the legislation is structured to be one size fits all. So what we're trying to do is create nuance and individualization that is matching needs to resources within our program, and then using what we learn to actually advocate for that level of systems change. So there's a continuum of care, there's a continuum of need, and there's a continuum of time that young people need to be in extended foster care, and there needs to be a better way to understand that and to match those things up.
Yeah, I really enjoyed Erica's the tool that Erica showed us, and I think there are a number of features of it that distinguish it from what I called a standard methodology, and I think for good reasons. I think the tool, on the one hand, it's context specific. It seems designed to take into account the challenges and subtleties of a particular type of application, as opposed to abstracting from everything and trying to give a fairness measure that people can just use by themselves somewhere. it has, if I understood correctly, it takes as input a stakeholder perspective and the perspective of people who are affected. This is very helpful for considering what alternative considerations we must take into account, given that all of us have certain limitations in our own perspective, right? And I also very much like this fact that it's something that unfolds, as opposed to considering it as a solution that we can give in, as if this is one intervention that we give at this point, and then we can say that our model is certifiably fair or something like which people do. I really like the fact that this, it was oriented towards the temporal process. That is, like, how can we monitor this as things unfold? And I think precisely the type of tool that should be promoted and should be considered as role model for many other tools that are out there that completely neglect what I think are essential feature of this type of issues.
Thank you. I will also add that the most time-consuming part of developing this tool was the meaning-making process, right? Getting under the hood, talking through the connections, getting feedback from practitioners, diverse perspectives from practitioners, and even from young people on what do these models really mean, and what are the associations that the modeling process is yielding and lifting up really mean? Is it relevant? Is it an artifact? Is it being confounded with other things? Does it actually reflect our values and our mission and the perspectives of those who are impacted and may use the tool? That took a long time. But I think the product, I mean, it's obviously the most important aspect of the work to make it fair, equitable, and reflective of what's meaningful to the communities that we're working with.
Thank you. I mean, I didn't want to put words in each other's mouths, but it seemed like the two of you were talking about very similar sorts of things. And Vinod, oh, welcome back. Did you want to provide a closing remark or two? Technology, right? I mean, this is the world we live in these days.
And I went through the entire talk without having any idea that I was disconnected. Sorry, I don't know what happened. I think I got thrown out of like the call. So yeah, I think the time is over. So I think the work that I was presenting was about like how the assumptions of Western-based algorithmic fairness do not transfer over. If you at least got the first 2 or 3 slides, at least it motivates the problem.
We got more than that. We got at least 4 or 5, I think. So we got pretty.
The results are less important because you can read the paper. I think motivating that often overlooked sort of implicit assumptions on like Western systems is what I wanted to make, and I hope that I did.
Oh, absolutely. And I think it certainly adds to the conversation that Erica started by showing sort of how one can do sort of an ethical approach to this kind of work, and then Sina's concerns about what, how we define fairness in the context of those things, and for you to come in at the end to sort of say, well, yeah, and fairness isn't fairness everywhere. The same, there's indic versions of fairness that one needs to think about even. So it's a really, it was a really fun set of topics. And I see Bistra has arrived, so I am going to let Bistra take over and introduce the next few panelists, and Ty is going to bring them in. So thank you all very much for your wonderful talks.
Thank you.
Okay, hi everybody. Welcome to the second session with invited talks, and it's my great pleasure to moderate this session, which is featuring Hima Lakkaraju, Maria de Arteaga, and Caroline Johnson. So let me start by introducing our first speaker, Hima Lakkaraju. She's an assistant professor at Harvard University and focuses on explainability, fairness, and robustness of machine learning models, working with domain experts in criminal justice and healthcare to understand the real-world implications of explainable and fair ML. Hima has received Best Paper Awards at SDM and Informs, and has given invited workshop talks at top AI conferences. She has also recently been named one of the 35 innovators under 35 by MIT Tech Review, and her research has been covered by the New York Times, MIT Tech Review, Time, and Forbes. Hima, it's such a pleasure to have you here.
Thank you, Bistra. I will just try to share my screen and hopefully this works. Okay, All right, great. Okay, thank you so much for having me here once again. Hi, everyone. Hope you're enjoying the workshop. So today I'll be talking a little bit about explainable ML, challenges and opportunities. Since it's 5 minutes, I just thought that I would highlight some of the critical problems that exist in the field and also just like add some tidbits about the work that we are doing. Okay, so I will be briefly touching upon these questions. So these questions are something that the community itself has been trying to investigate quite a bit these days, and also my group does a lot of work touching upon these questions. There is a lot of work so far in the past few years, at least, in terms of explaining black box models, right? So you have like a complex model, like a deep neural network, or just a black box model that we have no clue what is sort of the underlying functional form or what does it comprise of, but we want to explain those models. And why is that important? It is important typically in settings like healthcare or public policy or justice, where the decisions are often high stakes and we don't want to make any errors, right? So instead of just the model giving a prediction, you might also want to explain why a model is giving a prediction so that the end user, who could be a decision maker like a doctor or a judge, can look at it and then decide if and how they want to use the model's prediction. And the status quo, the state of the art, is that there are several approaches that have already been proposed which sort of try to explain complex black box models, right? So that's from 2016 all the way till 2019, 20, and even some of the ongoing work does that. But what we are trying to investigate is the following. The first one is understanding the vulnerabilities of existing post hoc explanation techniques, and to ask the question as to how can these vulnerabilities be exploited by adversaries to generate misleading explanations? What could be the real world impact of a misleading explanation? And how to mitigate the vulnerabilities of the post hoc explanation techniques that I just enumerated. So let me just walk you through some examples and some results to see what I'm talking about. The first one is, we are often discussing about, let's kind of explain models, let's kind of explain how a model is making a prediction, and, the decision makers, end users will know how to deal with it and so on, right? But we are not really testing out, while we are coming up with more and more algorithms, we are not really evaluating these with real users. If a judge will use this kind of an explanation, what would the impact of that be? And particularly what we did with some of our recent work was that we took a underlying model, which you see is both explanation and model. In this case that you see on the screen are both rule-based models, but on the left-hand side you basically see this classifier, which is a rule-based classifier and which is using race and gender as predominant features when making predictions, right? And then on the right side you see an explanation that essentially just replaces the race and gender, which are considered as illegal attributes to use in making decisions around criminal justice, with some correlates like prior convictions, prior crimes, zip codes, and so on. Right. So what we did was take a model which is biased or which is using race and gender as core attributes when making predictions in a legal context, and we replaced it with essentially a similar prediction making model, but where the problematic features are visibly replaced with their correlates, which look innocuous, right? And when we showed the second model, which is essentially an explanation of the first one, people were more likely to trust the underlying model. In fact, we did this experiment with some of the law school students here at Harvard and also UConn, and basically when they looked at the original model, they all had a problem with a model like this because it was using race and gender to make predictions. But when we showed them the model on the right side, or the explanation on the right side, everybody was okay with it because at least there are no visibly problematic features, right? So in some sense, what this highlights is there is both a need for us to sort of clarify what our terminology is. When we say explanation, we might mean something, but an end user might interpret it as something else, and also to educate the end users in terms of what they're exactly getting as an explanation, right? Otherwise, there could be some serious misinterpretations, serious mismatches, and we might end up deploying problematic black boxes. The second piece that I want to touch upon is this idea of understanding what are the vulnerabilities of some of the popular existing explanation methods. And one such method is called LIME. The basic idea behind LIME is pretty simple, right? So the goal is to explain the individual prediction of a classifier. Let's say in this case, you have this point marked by the red plus mark. So that is the point that whose prediction you want to explain. What you do is you take the point, you essentially perturb the point and generate some sort of a local neighborhood around that point, and then just fit a linear model on those points that you just perturbed the original instance and generated. Okay, so it's almost like saying that, so there is an underlying complex model that is doing some complex things, which you can see by the nonlinear decision boundary here. But we want to get a simple explanation of what the model is doing locally, which is in terms of making this individual prediction. So what do you do? Take that point, perturb it, generate a bunch of points around it, fit a linear model, and that linear model serves as an explanation as to what the underlying complex model might be doing around that point. Okay, so that is a typical intuition, and this intuition is used by a lot of other approaches which try to explain complex black box models. So while this looks reasonable on the surface, there are quite a few problems that might arise, and that's what was demonstrated by some of our recent work. Basically, if you see, this approach is relying a lot on the perturbations of an instance, right? So because that's on, you're building a whole explanation just on the perturbations way more. So what we did was we essentially tried to see what those perturbations would look like in comparison to the original data points, right? So we took a data set called as Compass data set, which is pretty popular in the fairness community. It captures decisions about if an individual would recidivate or not when released on parole. We did PC on it, reduced the data set to 2 dimensions, plotted dimension 1 on x-axis, dimension 2 on y-axis, and then we are just showing a scatter plot of the perturbations as well as the original instances, right? And what you can see is these red colored points, which are perturbations, are actually much farther away than the original instances. So in some sense, several perturbations are actually out of distribution. And why do I care about that? We care about that because adversaries can exploit this and build a classifier which is extremely racist on in-sample data points and which is extremely fair and innocuous on out of distribution data points, right? So because LIME is relying so much on the out of distribution perturbations, it will not even detect that this kind of racial biases are prevalent in the underlying classifier. So you can easily fool this method into thinking an underlying classifier is completely innocuous and not using problematic features, even though it is. Okay, it's a simple attack, but it can completely throw the algorithm off. And so I'm not here to just give bad news, but there are ways to sort of work around these kinds of problems. And of course, our group and also several other amazing researchers are working on them. I just wanted to highlight a couple of solutions before I hand it over back to Bistra. So one of the things that we have tried to address with the recent work is to make sure that post-hoc explanations are not unstable and very sensitive to changes in the data. Right. So that is because it's in order to produce an explanation that is faithful to the underlying model, these qualities become important. And how do we do that? We do that by sort of getting inspiration from ideas in adversarial robustness, where we can sort of leverage the minimax formulations that adversarial robustness and machine learning uses to also generate explanations which minimize the worst case loss in the fidelity or faithfulness across different possible data set shifts. Okay, I'll not go into all the details, but such an objective and of course solving the objective can potentially attribute both the properties of stability as well as robustness to data set shifts for the explanations. And the next piece is we also looked at this kind of uncertainty, modeling uncertainty in explanations. This was also motivated by a big problem in some of the existing approaches, where we found that even if you just rerun the same approach on the same data again and again, you are going to get different explanations for a variety of reasons, right? So the approaches are not even consistent. So if I repeatedly run the same Lime approach, it's giving me different explanations because it depends on the perturbation set. And if your perturbations are like randomly sampled each time, you're getting a new explanation each time. So there is a consistency problem. And in order to sort of work through that, we propose some Bayesian versions of existing approaches, which really capture the uncertainty given an explanation. So that is, something that could be useful to give guarantees on how good is your explanation. With that, I would just like to close by saying that explainability today as a technology is fragile. Research is still in progress, but that also means it's an exciting field to be in. Lots of things are happening. People are identifying problems with approaches, proposing new approaches. There is a clear need to improve reliability of explanations and to also develop evaluation frameworks and benchmarks to evaluate explanations, see if they're being robust against different kinds of attacks and so on. And another piece that is often underlooked in this literature is the scalability of explanation methods, which also I believe deserves a lot of attention. With that, I would like to stop here and over to you, Bitra.
Thanks, Hima. And we're going to answer questions, I guess, at the end of this session. So stick around. So I would really, it's my great pleasure to introduce our second speaker, Maria de Arteaga, who is an assistant professor at the University of Texas at Austin. In 2017, she co-founded the Machine Learning for Developing World workshop series at NeurIPS. And her work has been awarded the Best Thematic Paper Award at NACL, Innovation Award on Data Science at Data for Policy, and has been featured by UN Women and Global Pulse in their report, Gender Equality and Big Data, Making Gender Data Visible. Also, Marie has recently been recognized with the 2020 Google Award for Inclusion Research for her amazing work. And she also works at this intersection of AI and fairness and equity. And I'm really looking forward to hear from her today. Thank you, Maria.
Thank you so much for the introduction, and I've been enjoying the talks so much today. Let me share my screen. You're seeing my screen now? Perfect. Well, today I'll be giving you a brief overview of our work with Ricardo Fogliato and Alexandra Shodachova on a case for humans in the loop. And this is work that we presented at CAI last year. In many domains, we're seeing how algorithmic assisted decision-making is being deployed or considered for deployment. And this often takes the form of a risk assessment instrument. And these are predictive models that estimate the likelihood that a person or case will have a poor outcome. And applications of these include lending, criminal justice, healthcare, and what we focus on is child welfare. In 2016, Allegheny County deployed an algorithmic risk assessment tool that takes as input the historical records associated to the children and adults involved in a call made to the child maltreatment hotline, and outputs a risk score from 1 to 20, where high scores indicate higher risk, and flags some cases that are estimated at very high risk of out-of-home placement, meaning the child being placed in foster care as a result of an investigation. And so for these cases, the call worker requires supervisor's approval for screening out. Screening out refers to the decision that the call worker is tasked with making. That is, the call worker needs to decide whether a call is screened in for further investigation and a social worker visits the home or not. And the call worker also has access to the call itself, to the records that the algorithm uses for making predictions, and to the algorithmic predictions. There was a glitch in the system when it was deployed that led to some features being miscalculated in real time. And in turn, this led to the misestimation of the scores. Here in the x-axis, what you're seeing is the assessed score. So this is what the correct score would have been if the features hadn't been misestimated. And in the y-axis, you see the score that was shown to the call workers. So what you see is that there's a strong correlation between these, right? Most of these lie in the diagonal. However, 17% of shown scores were miscalculated by 5 or more points, and some cases that should have been flagged as mandatory screening were not. These led to us being able to ask the question, are coworkers able to dismiss algorithmic recommendation when the tool misestimates the risk? And we can frame this question in terms of algorithm aversion or automation bias, where algorithm aversion refers to under-reliance and humans just being very prone to dismissing algorithmic recommendations, regardless of whether they could or not improve the quality of their decisions. Whereas automation bias refers to over-reliance. And so in over-reliance, the human is just blindly following the recommendations. And a sneak peek into the results that we find is that we look at what happens when the score is misestimated. And in particular, here we can look at what happens when it is underestimated, for instance. And what this plot is showing us is the percentage of screenings for a binned version of the shown score. So correct indicates that the assessed score is equal to the shown score. Underestimation means that the score shown was lower than the assessed score, and overestimation means that the score shown was higher than the assessed score. If the coworker was blindly following the risk tool, then this should be undistinguishable in terms of the screening rates that we observe. But what we see is something very different. So if we zoom into one of these buckets, for instance, for the cases with a shown score between 11 and 15, those cases for which the score was an underestimation of the assessed score were screening at rates of almost 60%, whereas the others were screening at a rate of approximately 30%. And so what this suggests is that the coworkers make use of other pieces of information, whereas that's the call or the historical records that they also have access to, and respond by screening in these calls with higher probability. And so this is just a sneak peek into the analysis that you can see much more in detail in the paper. But basically what we find in this context is that the coworkers did alter their behavior when using algorithmic recommendations. They did not fall on the side of algorithm aversion, just complete under-reliance and dismissing the recommendations, but they were less likely to adhere to recommendations resulting from misestimated scores. So they didn't just fall on automation bias, blindly following recommendations. And with this, I just want to leave you with some of the lessons that we can learn from this work, where one of the advantages of this is that we have inherent field validity, even if we cannot say what led to this behavior, because we cannot make causal claims from these observational studies. But here we really need to emphasize that predictions are different from decisions. The predictions that we give to a human are different from the decisions that they're informing. And how humans make use of recommendations matters and varies. And while algorithm aversion and automation bias are real phenomena that we need to be concerned about, that does not mean that humans always make poor use of algorithmic tools. And so there is a lot of room for thinking about how do we develop algorithmic decision support in ways that improve the quality of experts' decisions. Thank you.
Thank you, Maria. Thank you very much. Very in-depth example of how to evaluate what's happening when we deploy this kind of systems. And so our last speaker in this session is Caroline Johnson. Caroline is a second-year PhD student in Industrial and System Engineering here at USC, advised by Dr. Phoebe Vallanos, and her research interests lie at the intersection of robust optimization and fairness and equity in AI, with a focus on creating positive real-world social impact. Caroline is a recipient of the NSF Graduate Fellowship and is also the student representative for the Center of AI in Society at USC. Caroline, take it away.
Thank you, Bistra. All right, let me go ahead and share my screen. All right, can everyone see? Awesome. So today I'll be giving the 5-minute spiel of our work, Robust Multi-Stakeholder Preference Elicitation and Aggregation for Patient Triage during the COVID-19 pandemic. So I think I won the competition for longest title, but who's counting? So yeah, this is joint work with Simon Blessenall and Phoebe Vianos. So something that was already mentioned today, earlier this morning, thankfully, is that during the COVID-19 pandemic, unfortunately, we've seen that in some instances, hospitals run out of resources to give to patients. They're just too overwhelmed. So they'll refer to what's called a triage policy, which we can see an example of one here. So this is in a form of a decision tree, which many of us might be familiar with, but essentially based on a patient's characteristics, it'll bucket you into whether you're a low priority for an available resource, a medium priority, or high priority, where then the scarce resources will be first allocated to those with high priority, and so on and so forth. And hospitals have what's called a triage committee, which is a group of people in the clinical field who are the ones who are deciding what these triage policies should look like and implement the one that's actually used in practice. But we all know when you're thinking about policies, there's different things you might want to consider. For example, we might want a really efficient policy where we save the most number of life years across those that are treated. We might want a really fair policy where we might save equal lives across race or age groups, right? We've seen a lot of disparities revolving these issues during the pandemic. But we all sort of know in group decision-making, people are bound to disagree, right? Especially with these topics between efficiency and fairness. We know we can't have things both hold simultaneously. Something's going to give. So how does this committee actually implement something in practice, right? Which policy will they actually use? So we've developed a preference elicitation and recommendation algorithm where we imagine we have a bunch of different candidate policies that this committee will have to choose from. And that the preferences for the policies, these stakeholders, their preferences are initially unknown. So using concepts from robust optimization and social choice theory, we'll then strategically select questions to gauge their preferences and eventually collect enough information where we'll aggregate these preferences together and then recommend an optimal policy to that group where it will maximize the utility of that group, where utility is just a metric that we use to say how much the group as a whole prefers that policy. So you can see a picture here of what that looks like in practice. So at each step, we're deciding which question to ask about someone's preferences and specifically who we're asking in the group about their preferences. They'll then report their preference back to us about which policy they prefer. And then we'll use that information to then select the next question to gauge about someone's preferences, who we're asking, so on and so forth, where we then elicited all of these preferences and again can aggregate them together to then recommend an ultimate policy to the group and sort of get them out of this sort of difficult collective group decision-making process. And again, can't really show the equations, obviously, but the key here is that we're using robust optimization and social choice theory to do this procedure. So to give some context for some experimental results that I'll show in a second, what we've done here is we created a bunch of different candidate policies where we simulated them using real COVID-19 patient data from the UK. So you can see an example of 3 such policies here, 1, 2, 3, and can't really get into the nitty-gritty, but the bar charts here are showing the probability of someone receiving a critical care bed unit based on their age group, right? So again, harking back to that notion of do we want fairness across different age groups? And then this red line is showing the number of life years saved by that policy. So for example, right, if I was asked, do I prefer policy 2 or policy 3? I might personally really value policies that have a high number of life years saved. So I would report back that I prefer policy 3. So that's just kind of an example of what kind of mechanically we're doing to elicit the preferences and right, what individual stakeholders might value over another. The main idea here is we use real patient data to simulate a bunch of these candidate policies so we can run a simulation using the work that we've developed. So to show some initial promising computational results of what we've done here, on this graph, on the y-axis, I'm showing the worst case normalized group utility of our recommended policy. So for example, here I can guarantee that our group utility is no worse than 0. And on the x-axis, this is the total number of questions we've asked so far in our elicitation procedure. So for example, this is what I can guarantee after getting information from just asking 1 question versus this is how much utility I can guarantee after having 15 questions, right? So we can see incrementally as we're finding out more information, we're able to raise our utility over time in general. So our method that we've developed, which again uses robust optimization, is shown here in red. In blue, we're just using a random procedure to select the elicitation, so nothing sort of disciplined in that sense. And then green is an analytic center method, which is from the Bert Seamas and O'Hare reference that I've put below. So you can see this band is over many different simulations. So our method in red is maximizing the utility on average more than the others, which is great sort of promising initial results that we have here. And again, just to kind of wrap up, the idea is that there are these very difficult kind of group collective decision-making processes that are happening. How can we sort of muddle through people disagreeing in these important situations? And we've developed a sort of disciplined way to help guide them through that process. Thank you.
Thanks, Karen. Great. Well, I guess we have like 3 amazing projects being presented in this short session. So if anybody has questions from the other panelists or from the audience, feel free to jump in. But I guess I myself have several questions, and they kind of connect, I think, the 3 talks to some extent. I guess my first question was actually to Hima, and listening to the talk raised a kind of an important question in my mind, is whether we should be thinking about legal requirements for explanations, right? So in a sense, what you presented with the adversarial explanations is that in a sense, people can use that to misrepresent their model, right? And as these kind of models get deployed in sensitive areas like the one that Maria presented, if we're using explanations in order to gain trust, should we have some requirements on how people are generating those explanations so that any trust that is granted is actually deserved? And what are your thoughts on that?
Yeah, no, I think you're absolutely right, Bistra. I think the more we sort of rely on these kinds of things and start putting them out in the real world and actual applications, the more there is a need for some kind of legislation, regulation around it. I think the field is sort of still nascent enough that at this point, you know, a bunch of approaches came out, and now everybody is trying to figure out like what are the potential vulnerabilities, who can attack it in what way, and so on. So hopefully it will take a few years of all that flux, and then we'll reach a point where the field will be a little bit more mature enough to sort of be more clear in terms of what is needed in which setting and what are the limitations, what should the regulations look like, and so on. And then I think we'll be in a position to sort of get ahead in that front. But yeah, I definitely agree with you that there should be more stringent checks on these, checks and balances on these, both in terms of when we develop those methods, we cannot just be complacent that, oh, there is, you know, it seems like on some metrics it's working, but we also need to be like aware that we need to be more critical ourselves. And at the same time, we need to like look ahead and think about these kinds of regulation.
Yeah. Because people are already thinking in terms of fairness when you have algorithmic decision making about requiring some kind of measurements about disparate impact and so on, and explanations has been offered up as one way to mitigate that. But in a sense, you're kind of like delaying the responsibility. So if there was a legal responsibility, then that same onus should be on the explanations if they're going to take over that space.
Right.
But if you flip that question opposite, I guess I wanted to hear Maria's opinion on actually in terms of, you know, not to discredit explanations. I think they have a lot to offer. And so Maria, you talked about, you know, the fact algorithm aversion versus automation bias and in the context of child welfare. But do you think that explanations have a role to play there in order to dealing with those like kind of predispositions?
Yeah, that's a great question. That's something that, as I pointed out, one of the advantages of the work is that it has field validity. One of the disadvantages is that because we're not manipulating individual elements of the design, then we cannot make a claim of, for instance, in this case, there are no explanations, and we cannot make a claim of what would have happened if there were explanations. But I think that work like Hima's and other work that has looked at what are the impacts of explanation have started showing us that there's a lot of counterintuitive results there. That is, when you think about the work that Hima has done in this space and what that means for the risk of over-reliance in the tool, right? So one of the things that we have a short paper in which we discuss what are some things that could have potentially changed the effect that we saw? And we precisely point out at the work that Hima has done on would explanations have led the co-workers to overtrust the scores that were a result of misestimated features. And so I think that in that regard, it's important that we think about as explanations to a mean to an end and not an end in itself. And so in that regard, when you think about, if I want explanations because I want the human to be thinking critically about the predictions, is that what I'm actually achieving? Or is that just grounded on intuition that may not be reflected on how humans behave when I show them these explanations?
But it does seem that in your domain, in a sense, the social workers are able to correct, in a sense, the machine learning model, right? So when it's underestimating, they're able to evaluate themselves that they should actually refer people to the system and so on. I guess this is in a setting where it seems to me the predictive model was not bringing something very extra to the field, where, you know, the social workers themselves were actually more able to estimate the correct score better than the ML model. So I guess the promise of this AI-assisted data-driven decision-making is, I guess, in areas where we feel sometimes humans might actually not be able to aggregate on the spot as accurately the area and evaluate the score better. And by providing that, maybe allow for correction of the human bias. But maybe I'm wrong, but from the results you showed to me, it was more like actually the humans were more aligned with the true score, right? And it seems like they were able to estimate a true score on their own. So it almost seems like the ML model was just not a good ML model, was not bringing something to the table.
So not quite, because I just had time to show the overriding, but in the first part of that work, we also look at how they did change their behavior. And when you look at the deployment at the behavior after the deployment, it does align more with the estimated score than before the deployment.
Okay.
And okay. So yeah.
Sorry,
so
I guess I don't know that
it
part.
wasn't full. No, it's a great question, because it also allows me to bring in this portion that is, so it wasn't a case of the algorithm was not necessarily adding anything, but in adhering to recommendations, it was more likely that the co-workers were going to adhere to correctly estimated recommendations than to incorrectly estimated recommendations.
Mm-hmm. Hima, did you have something to say? I think I saw you like kind of reacting to our discussion with Maria.
Yeah, no, I think I was just kind of the points on over-reliance of explanations and so on. I think by now, I think it is pretty sort of well established. So I was just kind of nodding because I agree with the points, and we have often encountered that in some of the works that we did. So yeah, I was just kind of agreeing with the points Maria was making.
So to continue to pulling on that thread to Carolyn.
I'm going to have to stop because I think we only have 15 minutes left before some people might need to leave. So I want to make sure that we're going to be a little bit over time, but I want to make sure we get time to get the last thing, because I want to keep talking about this too. Trust me. That's why I was throwing some stuff in the chat box too. But Phoebe, do you want to maybe? So thank you all so much, and go ahead, be straight.
Thank you. Yes, sorry, I was not keeping track of time. I'll ask my question to Carolyn on the chat.
Sounds good. Thanks, Bistra.
Thank you, everybody.
Thank you.
So we have 3 more speakers now for this last session for this morning/afternoon, depending on where you are. And so I'm going to start introducing the first speaker, China Hill. So Dr. China Hill is a postdoctoral researcher with the Center for Artificial Intelligence in Society. And she's the community-based research lead on the Coordinated Entry System Triage Tool Research and Refinement Project. Recently, she obtained her MSW and PhD from the Susan Dvorak Peck School of Social Work at the University of Southern California. Her work explores the complex nature of Black homelessness. Her research explicitly elucidates how historical inequities and byproducts of discrimination hinder Black people from obtaining and maintaining stable housing. I cannot see China, which is interesting. I'm pretty
It looks
sure
like she just re-entered the main room, and so I think she's being promoted. I think she just raised her hand asking if she could be promoted.
Thank you. Sorry about that, China. Please go ahead.
Hi, I am here. Gonna share my screen. Alrighty, so my name is China Ho, and I am a postdoc at USC. I am going to share one of the chapters from my dissertation where I wanted to look at stability at 180 days across racial and ethnic groups using data from the ORG codes. So for this analysis, I decided to use classification trees because I wanted to see the rank orders of predictors of remaining stably housed for 100 days or more. And I wanted to see the racial and ethnic breakdown of this. So in terms of the data that I use data from the Homeless Management Information System. It consisted of about 10,250 youth. I excluded other youth of color because I didn't have enough to categorically break them apart. So I was left with white youth, Latino youth, and Black youth. My research questions are as follows. What are the predictors of remaining housed for 180 days or more for Black youth? Do the predictors of remaining housed for 180 days or more among Black youth mirror those of white and Latino youth? And then what predictors hinder Black youth from remaining stably housed for 180 days or more? So I initially started with a huge list of variables, but to narrow that list of variables down, I did some bivariate models, and I chose to enter the variables that were statistically significant with my outcome, which was remaining stable 180 days or more. So these were the variables that I was left with after that exercise. The trees are kind of small, sorry about that. But here's the trees for white youth. You could see engaging in rapid rehousing was important, as well as exiting to family or not. Shelter appeared as an important factor, as well as self-resolving, and then the number of police interactions. This is the sensitivity and specificity and the area under the curve and the misclassification rate for all of the trees. I think I included it on each of the tree slides. So what you can see here though is that engagement in services is really important in terms of who remains stably housed for 180 days or more. So entering rapid rehousing versus not, and then also whether they exit to family versus not, and then self-resolving versus not. So having more formal supports in place are pretty important for white youth. And then for Latino youth, we also see that service engagement here is important. So whether they exit via rapid rehousing or not, and then service use. So if they had ER ambulance use, and then if they reside in a rural community or not. Rural possibly came up because there's probably less services in rural communities, so they have less access to exiting homelessness and remaining stably housed. And you can also see that family also came up in the tree of Latino youth again. So if they did exit to family, they were more of them remained housed than not exiting to family. And here's the tree for Black youth. Again, we see that service engagement is important, specifically exiting homelessness by rapid rehousing. What's interesting about Black youth is exiting to family doesn't appear in their tree as an important predictor of remaining stably housed, while it did appear in the tree of white youth and Latino youth. And then again, here's a table of the factors that were most important here. You can see again, for all youth, exiting to rapid rehousing was important. For all youth except Black youth, exiting a family was also seen as important. Exiting via self-resolve, then shelter, then crisis services. And then just some high-level summaries of the results. So formal networks of support are critical to youth maintaining housing stability for 180 days or more. And then service engagement is an important predictor of remaining stably housed for 180 days or more. And then just some limitations of the study. I would have liked to use 365 days or 730 days, but I just didn't have a large enough sample to do that. It includes data on service use before the exit, but I don't know what happens after youth are referred to rapid rehousing and how services they receive in rapid rehousing makes a difference if they receive any at all, because that might have impacted who remained housed for 180 days or more and who didn't. And then I also don't know at what point rapid rehousing is successful. So is it at a year? Is it at 3 months? Is it at 6 months? And then I just have limited visibility into other resilience factors. So if they're getting financial support from elsewhere, if they have family support, or if they have ongoing support services from like independent living services, or if they are in foster care. And so implications, it seems that rapid rehousing is really critical for youth who are exiting homelessness, but as we know, there's not enough rapid rehousing vouchers for every youth experiencing homelessness. Rapid rehousing is also a short-term rental program, so after that expires, youth are kind of left to figure it out. Hopefully they've attained stability by then, but if not, does that mean they return to homelessness? We don't really know. And then just emphasizing the importance of service engagement with youth remaining successfully housed. And that's it.
Thank you very much, China. Very interesting work. I'm gonna move along to the next speaker because we have so little time. So our next speaker is AJ Kamar. AJ, are you there?
Yes, I'm here. Hi, Phoebe.
Hello, nice to see you.
Nice to see you too. Nice to see so many familiar faces today. Can you see my screen?
I can. So let me introduce you before you get started. So Dr. AJ Kamar is a Senior Principal Research Area Manager at Microsoft Research in Redmond. She oversees the research on human-centered AI. Her research investigates problems at the intersection of AI systems, people, and our society, exploring how limitations of AI systems lead to concerns around biases, reliability, and safety problems, investigating novel ways for AI systems to support people, and finally developing frameworks for human-AI teamwork for complementarity. AJ also serves as the technical advisor of Microsoft's company-wide Committee on AI, Ethics and Effects of Engineering and Research, AETHER. In her advisory role, she consults product teams at Microsoft on issues around responsible AI, helps to develop best practices, tools, and guidance to support the development of responsible, unbiased, and reliable AI systems for the open world. Looking forward to your talk, AJ. Thank you.
Thank you. Thank you, Phoebe. Again, it is so great to see these familiar faces. I would usually come by to LA once a year to visit you guys, and now we are doing this virtually. I know I only have 5 minutes, and by looking at the program, I've seen a great coverage of the issues we know that exist when we put AI systems into the open world. So I will not go into these examples or a particular research problem we are doing in here. What I kind of decided today in the 5 minutes is basically tell you what this problem looks like from an industry perspective. What are some of the actions we are taking on this space? I thought this would be complementary to the other things that panelists are covering today. I know it's going to be a different perspective, but I chose it particularly for that reason. So I'm sure many participants have seen principles coming out in the last few years about putting AI systems into the open world. Microsoft was one of the first in this. I think it was 2016 when from the CEO level, these principles were introduced into the world, that our system should be fair, reliable, they should be inclusive, they should be accountable, and so forth. However, what we've seen in industry across all of the companies involved is that putting the principles out there is the easy part. How do you actually bring them to reality is a very complicated technical, organizational, and social problem. And that's what I want to talk about today. So right now, we are actually seeing that our organization in the company is maturing. Initially, it started from research, and this is one of the things apparently research is really good at seeing these problems coming up and saying, what can I do? So that is how I and many of my colleagues got included into this work very early on, and we've been working on for the last 4 years. And research has been very active in the company, driving the work, driving the organization, and that's the structure here we have on Ether. But research is not enough. Research is very good at creating awareness, but then there needs to be other pieces of the puzzle that needs to come in to move the needle. So now we have a legal component to this puzzle that is now talking about compliance, a standard that all teams need to go through. And now we also have an engineering arm called RAISE. And within this, we are trying to reach into all of the product groups doing this. But of course, the organization is not enough. And my research team has been thinking a lot about these problems. And I was thinking for today, like how I can summarize my view on responsible AI very succinctly. And the sentence I came up with is, we need to acknowledge that people should be in the center of why, how, and what we are building in the industry. So that's what I mean by computing systems are developed by people, for people, and with people. And I think if we don't have this view, then we are missing the point in many cases. Let me start by developing systems for people. Right now, there's a big rush in industry, try to put AI everywhere. And I think one of the problems is that we are not building what is useful, we are building what is convenient to build. We are getting attracted to things where there's a lot of data, there's a lot of labeled data. We can measure the accuracy very easily. Does those applications correspond to what people really need to create value for our society? No, we are not. However, that does not mean that we will not get a lot of value from AI systems. I personally think that there is a lot of complementarity that exists between human intellect and machine intellect. And when we find these places of complementarity and connection, there is a lot of value we can create for the world. However, the way we are building AI systems is not really getting to this complementarity. What I want to say here is that we are doing automation and we are expecting collaboration to emerge from this automation. We are automating decisions and saying that if I put the system in front of people, they are going to get a lot of value from it. No, that's not the case. Studies over studies, including our own work, show that even when we put explainability, like a lot of the work that Hima has been doing, on top of these systems, collaboration is not coming out. We are seeing that just putting interpretability there as a patch is not really making collaboration to work. And that's one of the areas that my team is looking into more and more. How do we build AI systems for collaboration? In this particular work, I put the link there in case people are interested in. We are actually thinking about like how I can change the objective function of an AI system to put collaboration in focus. How I can actually say to the AI system that when you are learning to do a task, try to do the things that the humans are not good at, and how can we do the end-to-end learning frameworks today and train it for this objective. Coming to the problem of developing systems by people. Developers are spending their lives in developing AI systems, and our tools currently cover the 10% of their work, and the 90% of their work gets unsupported. When we say, okay, we need to think about biases, we need to think about reliability, developers come back to us and say, how do I do this? So one approach we are taking here is thinking a lot about guidelines and tooling, and we have actually done quite a bit of work in this space. We have tools for fairness, error analysis, interpretability out there, but we are seeing that alone these tools are not enough. We have guidelines for human AI interaction. Again, now it is the time to come together as a community and say, okay, we have some puzzle pieces now, how do we bring it together? And finally, the last observation. We have to acknowledge that the problems we are facing are socio-technical problems, and we need human-centered processes. These are not only technical problems. When we get to a problem like facial recognition, which I've spent really like months thinking about in the company on this with some of my colleagues, we see that use cases matter a lot. It's not only about the model, it's not about the technology, it's about how that's put into the world. When we look into facial recognition technology supporting people with disabilities, right? Versus using of the same technology in the field for surveillance, the risks are significantly different. This is why it is so important to bring diverse voices into the picture and have human-centered processes to decide what we should be building and how should we be building. And it's important to acknowledge that there are some technology that we should never build because the harms far outweigh the costs. Finally, we are also facing a lot of cultural, organizational, and technical problems. When teams come in and they are fully committed to building responsible AI, let's say, right? How does that compete with the business objectives? If they need to take another year to really get it right, do we have the management support to do that? And then I am working in a company where diversity is definitely an issue, like many other tech companies. How do we actually bring these diverse voices into the picture? And then for developer teams, it is very difficult for them to work on under this ambiguous space where there is not necessarily one single correct answer, or there is no silver bullet solution to any of the problems we are talking about. So I'll just stop there and looking forward to the panel. Thank you very much.
Thank you so much, AJ. You packed an incredible amount of information in these 5 minutes. I really appreciate it. A lot of food for thought. So our last speaker for this session is Elisa Celis. Am I pronouncing this right, actually, Elisa?
Yes, Elisa. Yes.
Good.
Thank you.
So Elisa is an assistant professor in the Statistics and Data Science department at Yale University. She studies the manifestation of social and economic biases in our online lives via the algorithms that encode and perpetuate them. Her research leverages both experimental and theoretical approaches, and her work spans multiple disciplines, including data science, machine learning, fairness in socio-technical systems, and algorithm design. Elisa, please go ahead.
Okay, thank you so much for the introduction, and thanks for having me here. It's been really nice to see a lot of familiar faces throughout the day. Lots of people I haven't seen in a couple of years now, so it's good to see you all in this, even if it's in a virtual format. What I wanted to talk about today is a kind of shift in terms of how I've been thinking about diversification in algorithmic systems over the past couple of years in conjunction with Vijay Keswani, who's one of my graduate students. And basically, to kind of start out with an example that many of you are perhaps familiar with, Kay et al. In 2014 pointed out that if you look at many online algorithms, such as image search, when you search for some kind of image, in this case, CEO, what you end up observing is a skewed perception of reality. In the real world, already there are more male CEOs than women who are CEOs. But what you see in terms of the images that are represented is that that balance is even more skewed. And this held true for just about every profession that they looked at, and this has been replicated even last year. So this problem has not gone away. And I just use this as one example problem of representation in an area in which, for many reasons, we would like to have a more diverse summary or a more diverse collection of images, of text, of viewpoints, of any number of things. And in the past several years, there's been a lot of work from many excellent researchers, some work from my lab, just all over the place, coming up with really nice, clever technical solutions on how to address this problem. And many of those are applicable to many, many settings, and definitely are helping as one piece of the puzzle in terms of striving for ethical AI systems. But there are also problems with applying these approaches generally, which appear widely in the wild, right? And one of the problems which appears, for example, for images, is the protected attributes, right? The race or the gender or the other attributes, for example, of images is a priori unknown, right? It's a picture. We don't have that label encoded into our data. And again, this holds true for many other applications. The other problem that appears is that these protected attributes are often very brittle. There's only one or two or three that we can kind of capture, and they're not capturing a real perspective of the world in many of our papers and many of the applications that are implemented. For example, gender is coded as binary, and it's not capturing the nuance of any of the reality that any of these protected attributes actually holds. And lastly, even once you have a really nice algorithm that works really well, for any particular application, you still have to figure out, okay, what are the attributes that we want to figure out? What is my measure of fairness? That's my target. How am I capturing all of these things? And those are very complicated problems that, as several of you have pointed out, are very human problems, right? And the people who are most impacted and we would most want to be a part of our decisions aren't always, or even aren't usually, the computer scientists or the statisticians or the people who know the technical side. So how can we bridge this gap? And is there a way to basically implicitly, in a very layperson friendly way, capture what we mean by diversity and then use that to solve these kinds of problems? So to do this, again, along with my student, Vijay Keswani, we try to have a very simple framing of the problem, which is to say, okay, can you show me, again, for images, starting with images as an example, can you show me what diversity would look like, right? Because while you might not be able to get someone to write down a mathematical formula that captures what diversity means like for them, they might be able to show you via a collection of images what diversity means, right? What does diversity mean like, again, for this image context? And now the question is, can we use this form of communication as a way to capture diversity and then have our algorithm encode it? And what we do here is we take a very small set of visibly diverse images and then a similarity function. I won't go into the details, but there's various ones you can use that all seem to work pretty well. And we can measure in our data set, you can kind of think of this, and you can do this implicitly also, having a matrix of similarity between each of the images in your diversity set and each of the images that you actually have in your data. And the way that summarization, in this case, image summarization algorithm might work, again, in a very simplified cartoon form, is that you have your data set, you have a query, you have some matching algorithm. I don't even necessarily know what that is. And then you get, you have some kind of score or some kind of output, right? Some ranked outputs. And what we propose here is to add this control set, right? This diversity control set with a similarity matrix, and basically just combine those scores in a particular way along with our usual query score. And again, I don't want to kind of get bogged down in the details, but yet now you get a balance that when you go through, basically what you'll end up doing is for each image in your sets, you first say, okay, what is a good image for the query that also looks like this image in my diversity set? Okay, so we put that one there. Now for the next one, what is a good one for the query that looks like this other image? And so on and so forth, and we can round robin around so that at the end of the day, we get a summary that is visibly diverse in the same manner that your visual representation set was visibly diverse. And we've been happy with the results that we've managed to get here. This is one query of smiling, and what we're doing is, again, combining these sets. So if you just do a query of, again, this is a Celeb data set that you might have seen in a black box algorithm, and you do smiling, you primarily see women, and you primarily see white women specifically in these middle row, which is these smiling pictures. And the top row is just, if we're just looking at our diversity score, you have some amount of diversity there. And if you combine the two, now you get a mix. You still get pictures of people who are smiling, but it's a more diverse collection. And you can do this for a variety of situations. So this, I just wanted to put this out as an approach. I think it's particularly nice because it doesn't require that labeled data. It doesn't require explicitly coming up with a mathematical formula. And it's something that is perhaps more easily workable when we're trying to move towards these collaborative solutions with key stakeholders who are not the technologists. And again, this was just one particular application where we did this with images. We have also tested this out with text, and we're trying it out on a couple of other applications, and it seems to be something that is generalizable. And with that, I hope we still have some time for questions. Again, thank you so much for having me. It's been really great to listen in today.
Thank you so much, Elisa, and thanks to all of our panelists. So I'd love to open it up for questions. Please start posting in the Q&A. And in the meantime, I can probably start with a question in particular. For AJ, can you tell us a little bit more about how you propose to build collaborations between humans and AI? You kind of hinted at this paper with Brian, but I'm really curious. So what's like the big level picture?
Yes, thank you for asking that so that I can have 2 minutes now to expand a little bit on that. Our observation there is that when we look into how people are performing on tasks, there is a structure to the things that people are good at, and there's a structure to the things that people are not very good at. So for this, we actually took a medical data set and did some analysis on what are the cases that people are struggling with. And these are medical doctors. And it was actually so interesting to see that the error space where there was a lot of concentration of human problems could be characterized by like 2 features. So that it really gets into the question of like, what are the reasons that people are not very good when they do things? And what we can actually do is that when we are training a machine learning model to perform the same task, right now those models are trained to get as much as possible on a particular test set. Try to get as much of this as possible. However, if these systems are built to complement people, and there's going to be a human that can address some of the problems, that means it is actually most important for the AI system to focus on things where the humans have a relatively lower performance, because then the machine can get those tasks, and the things that the humans are really good at can go to the humans. So what we actually do is that instead of using the standard objective function for the machine learning model, where you basically tell the machine, get as many cases as possible, we give a higher priority to the things that the humans are struggling with. And that's basically weighting those instances a lot higher than the instance that humans are very good at. And we have a value of information approach that kind of guides this process automatically so that we can do this optimization end to end. So basically what goes into the optimization is a database of human cases, what humans get right or wrong, and the objective function automatically learns what to put more emphasis to by querying that human database.
I see, very interesting. And so then how do you use it in the end? Because like in the end, you would need to tell the human, oh, don't use this one, you would get this one kind of anyway, right? So
Yeah.
how do you make recommendations in the end?
So that's actually a very important point. In the current version of the work, the machine actually makes decisions about routing using that value of information computation in the middle. However, that raises an issue about accountability, because we know that just because the machine thinks the machine is better at something may not actually be true when we put these systems into the open world, and there may be new cases that could actually fail the machine's perception or the machine's reasoning here. So we want to do further experiments where we actually put the human in the center, and we want to give the human these clues by saying, on this kind of a data set, it looks that the machine is very competent and the machine thinks this is the answer. Now, take the initiative and decide what you want to do. Of course, there's still a lot we don't understand yet about how to make that interaction really, really good, so that we are still giving autonomy to the human. We are not falling into the issues of automation bias, but we can see this complementarity coming up.
I see. Thank you so much. Very interesting, AJ, and very different point of view from like what we see usually as like automation, right, in machine learning. I have, unless there are questions in the chat, I actually have one question as well for Elisa. Elisa, can you tell us a little bit more about the data that's required as input to your approach? I didn't quite get that. So how do you measure initially diversity. So do you need, for example, in the CEO problem, you need all pictures of CEOs and to ask people to judge how diverse it is, or you can kind of transfer knowledge from the CEO problem to another problem?
Yeah, that's a great question. So it's a single visible diversity set, and then we use that same set for any query. So we're not going to have to do a case specific. Now you all look frozen, so I hope you can still hear me.
You have
but
we can
now you don't have to use a query specific set.
Mm-hmm. So what does this?
Yeah, and the
mm-hmm. Sorry,
I think I'm freezing in and out. I hope you can hear me. I think the other point is that if you're doing this internally, then you can kind of do the pre-processing of it. If you're doing it externally, you can still kind of use it as an outside filter. So you can basically use it to either audit systems, or you can use it as a kind of filter to pass. You kind of get 100, 200 images, whatever, from the system, and then you can rearrange them using your diversity control set.
I see. But I mean, a diverse set of CEOs may look very different from a diverse set of ballerinas. Still, it extends from one field to the other. That's what I'm trying to understand.
So that's, so yes, so some things can get, I guess, too far. If you're looking at images of people, it seems to work well. Now, if you want to, like of professions, right? So we were thinking about professions, so you use those same set of 90 professions and it worked well. Or if you are, so in regard to text, we were thinking about different dialects. So if we want to summarize, say, tweets, but we want to get a diverse set of inputs, so people who speak very differently based on dialect, then you can, then the topic that they're talking about doesn't matter so much as the kind of grammatical structure which can be captured. So there does seem to be essences that you can capture in a diversity control set. Now, if you're searching for, I don't know, maybe landscapes or something else, then that's a completely different problem, right? So we were kind of focusing on images of people.
Okay, very interesting. Are there any more questions? I know we're way over, and I really appreciate that all the panelists and all the participants stayed so late. Sorry for running over. Any last questions?
I don't think we've got any questions in the chat. I think I was just putting out some thanks to people in case they were filtering on their way out, and I also would like to thank all the panelists, and I think many of the attendees who are still here are amongst the panelists, and so thank you for participating. And it's been such a fascinating morning or afternoon, depending on where you are, and I'm really looking forward to tomorrow, and hope that many of you can join us again tomorrow. And we'll be putting this online as well, so that folks can get a chance to see this if they weren't able to be here in person this morning, because I think that this is some really fantastic stuff that really deserves to be highlighted and thought through more as we move into this world where there's increasingly AI solutions for so many things, and where we're thinking about these issues of fairness and equity are so critical. So thank you all so much.
See you all tomorrow. Bye.